If anybody gives me a hard time for uploading and or singing this, then I don't want to sing with you. And if you think I'm ignorant, maybe because we have different beliefs, well, that's on you. Maybe you haven't looked into it, maybe you have, but hey, we don't have to agree on everything. Let's do this. Something's going wrong in the neighborhood. Why do we see further than we should? All around us, people unaware, lied to and deceived without a care. There simply is no curve inside. You know we don't spend all day and night. It seems they want our minds flooded with lies. If you wanna bust the globe, I know these guys. Who you gonna call? Who you gonna call? Who you gonna call? Who you gonna call? Ghostbusters! Ghostbusters! Who you gonna call when the horizon flattens out? Go ahead, call them up, see what that's about. We can go around in circles trying to find this out, but if we looking for the truth, about to find it out. NASA can't go to space, so we hit the roof. Get it, hit the roof, and it all came to light with 200 proofs. Whoa, now I'm just really sick of people lying to me. So when I tell the truth, don't come crying to me. Pick up the phone, get on the line with me. Line with me. Who you gonna call? Who you gonna call? Ghostbusters! Ghostbusters! I can't help myself. Globebusters. Yeah. That's right. Oh, man.
And welcome everybody to Globebusters Special Edition, Incoherent Dielectric Acceleration. I'm your host, Bob Xanadude60, and we are back tonight with a special edition, and this is something I'm actually going to start doing as more of a regular type of thing, because I want to get more into subject-specific type of things, and in so doing, I would like to have it so when we discuss something, we will bring up a subject matter, we'll bring up our basic take behind it, and also at that point, I would like to hear from the community about where they think it is. But it does come with some caveats, and the reason for that is because I've listened to so many different shows and so many different debate shows, and over and over and over, it's like you constantly have to go back and re-educate somebody as to what you're talking about to even get them up to speed. So I figured, well, then the best way to do that is to kind of assign some homework. Okay, now if you guys look in the show description, you will see that there is under the show notes, there are several articles, web pages, YouTube videos, things like that. These basically are going to be the so-called homework, okay, that I want people to look into so that they are aware of where we're coming from and what's going to be discussed. And, I think that that will help things go a lot smoother, because the biggest part of this is, as far as I'm concerned, is just straight up misunderstanding, right? It's oftentimes a term that is misunderstood, or a concept or something like that. And so, I really want to try and get everybody on the same page so we can at least talk about it. Now, as far as having, opposing positions, well, that makes it even better, doesn't it? Right? If we're all on the same page, we understand the same subject matter, and if somebody has a different take on it, that's great, because the whole idea about this here is to learn about it. And I'm certainly not 100% married to the stuff that I am going to be talking about today. And I don't think anybody is on the panel that's here with us today. Obviously, we do not have the normal Globebusters panel with us today, but that's okay. We have a bunch of other people, and this, again, is part of the new show format. So, yeah, so let me go ahead and introduce our panel that's with us today, and then we'll kind of continue talking about, where we're coming from on this and how we're going to handle this. But first up, you guys probably know him. He's been staying with us for quite a while. His name is Zach Zabala, and his channel is called Good Times for All. And Zach is, of course, a dear friend of mine, and he is the one that is kind of the gifted person in the household as far as making videos, especially when it comes to, the technical expression of them. He does a really super good job. And so I'm really happy to have him on the panel today. So say hello to Zach Zabala. How you doing, Zach?
Hey, Bob. How's it going, man? Yeah, doing good. Got some rain today for the garden, so it was a good day.
Cool.
And the house didn't get blown away, so that's another plus.
Yeah, no kidding. Yeah, we had a major tornado. They were talking about, tornado warnings. We had all the phones going off. We thought, we were going to get blown away, but there was a really vicious storm for about 20 minutes, and then the sun came out and it was beautiful. So love it. I like that kind of weather, that's for sure. And okay, so also with us, and you guys probably know him. He is working on the galvanic cell model of flat Earth, about Earth essentially being a battery. And to that much, I have no doubt, because everything about this place is an electrical construct. Now, whether or not it specifically, ties to a galvanic cell, well, I don't know. We'll see. We're going to go there. We're going to find out. And we're going to look at not only his model, but a few other models in addition to that. And, kind of form a discussion over that. And he is LCKing, and that would be Lucas. How you doing, Lucas?
Doing well, Bob. Thanks for having me.
Awesome. Glad to have you here, man. So, okay. And then the third person we have with us is a regular panelist on the Iron Realm Media. And John has done a lot of really cool videos, especially back in the day. He did a lot of gyroscope videos, especially when we were really pushing hard on, what it meant to get these test results back from the gyroscopes, and that they were, in fact, quite easily sensitive enough to measure a 15-degree-per-hour rotation, and yet never did. But John did a lot of really great videos on that, and he's got, don't you have another web page also, John, which I don't think I put in the show notes?
Oh, blimey, don't ask me that, Bob. I can't remember what it is. I'm sure it'll come back to me. But yeah, no, cheers. Hi, Bob, Lucas, Zach. Looking forward to this. I've been into the electric universe since probably way before flat Earth. So to me, it always seemed like a no-brainer. So I'm looking forward to listening to someone who's actually broken it down and done the research and drilled right down into it like Lucas has. And not sure I'll be contributing much, but it's great to be here.
Okay, well, that's certainly not a problem, but just chime in whenever you want, and I'll cover it. I've got several things to do here. Guys, we are definitely going to be watching some video clips today, no doubt about that. Because it's much easier for me to play it directly from the video makers themselves. You may or may not have already seen them, but if not, then that's great, because we can all kind of watch it together and learn together. And if you have seen it, it's good review, especially if you are intending on participating in this discussion with this. All right, so what this comes down to, okay, like I titled the show, I called it Incoherent Dielectric Acceleration. People say, what in the hell is that? Okay, well, this is something that is a product of the luminiferous ether mechanics. And many of you have heard me talk a lot about the ether mechanics. I'm the guy that is famed for the 15 degrees per hour and 16 degrees per hour and 17 degrees per hour and 18 degrees per hour. The globers don't ever tell you that part of it, but it turns out that when you change elevations on the same latitude lines, you get all kinds of different degrees per hour. Why? Because you're not measuring Earth rotation. You are in fact measuring the vortexual properties of the luminiferous ether. Now, this is something that has been done before. It's going to be done again. In fact, I think this is going to be one of the things I'm going to try and get the producers of this TV show that we've been kind of having woo us to spring for another ring laser and or fiber optic gyro, so that we can go out and redo these demonstrations. Anyway, that's just something that one of the other things that we're going to be carrying into, but I won't go too far into that. But incoherent dielectric acceleration is basically, a model that's something that I think most of us probably picked up from this, from a guy named Ken Wheeler, or theory apophysis. Okay, so Ken is probably one of the world's foremost experts in magnetism, and I mean this is not even disputed. He is world renowned when it comes to the thoughts on magnetism. He has written several books on it. He's currently on his 4th edition of, I think it's called Missing Magnets, or Missing Secrets of Magnetism, which I have that book. And it's just, he's amazing. I mean, this guy is somebody that is an absolute next level thinker. And when you really break down what he is saying and you finally understand what the hell it is that he's saying, it starts making a whole lot of sense, right? So that's why, I kind of latched onto this, and a lot of people are beginning to realize this also. So now the problem that we're having right now is when we're talking about incoherent dielectric acceleration, Ken talks about the fact that incoherent dielectric acceleration is actually a field modality of several different manifestations of the luminiferous ether. Okay, and when he says that, what he's talking about is that he's saying that one of the modalities of the luminiferous ether is electrostatics, another one is gravity, and another one is electromagnetism. All right, so electrostatics or just electricity, however you want to look at that. So he's saying essentially that these are all the very, very same thing. And the way that he breaks it down, it actually makes a lot of sense. And so we have kind of taken his work, and Zach has made some really nice videos that kind of explain it. And we're trying to move forward and get this more into the mind of the community. So I guess the first thing I want to do is I want to share
real quick, Bob. Can I
certainly.
say one thing?
By all means.
And what Ken is saying, what he's in his videos, what he's trying to get across is what is taught in mainstream physics at college level courses. It is this electric, universe that we live in that is creating the up and down here on Earth when he's talking about gravity. Now, gravity, according to the maths and the way the physics teachers, teach it, is about bodies orbiting each other. That's what gravity is in free space. They are electrically neutral. There's no, field in between them connecting them. And this is how it is taught in mainstream physics today. I mean, Walter Lewin was teaching it at MIT back in 2000, I think 11 is when his videos are from. So yes, this is taught in physics today. It is not taught that gravity is making the downward bias here on Earth, at least. That is bigger bodies that are not electrically connected in any way. That's what they're talking about when they mean gravity. So Ken is actually teaching exactly what they teach in college level physics.
Yes. Yeah, that's absolutely true. And, in this video that we're going to be showing, we have none other than MIT professor Walter Lewin saying just that. You get the words right out of the horse's mouth, where he talks about, on a subatomic level, you have one set of forces, and then on the other On another level, you have electrical forces, and then finally, when you get out to the large things like, and granted, he is a baller, right? So obviously, he's going to say that's when gravity takes over. Now, mind you, that's very interesting because the current concept of gravity, right, is something that people, the reason they hate it, honestly, especially most flat earthers, is because of the way it has completely been misused. And they have tried to take this model of what gravity, started out as being, and that is nothing more than an acceleration or maybe even an attraction, right? They've called it a force, and then they had what they have, George Musser, right? He comes out and he goes, well, you can think of it as a force, but it's not actually a force, right? Well, no, it's not a force because it's an acceleration. And there's a definite difference between a force and an acceleration. And, I've talked a little bit about, I wondered about that before because, it was always an axiomatic law of physics that when you had an acceleration, there had to be a force that caused it. And that may or may not actually be true, but nevertheless, they are still two very different things. And so what they have done is they've taken the actual true definition of gravity, or not gravity. Well, the true definition of gravity means weight, right? But and what they made it sound like is that it was this mass attracting mass, on a planetary and a universal type of level, right? And we know that's nonsense. It's complete nonsense. But if it does it on their reasoning, of course, is if it's doing it on a small scale, then it's doing it on a large scale, and that is absolutely not true at all. And in fact, mainstream science knows full well what gravity actually is, or what they're calling gravity. And they even name their technologies, after it so that they can measure what it actually does. Okay, so what it actually is an acceleration. And what that acceleration is the thing that we say is this thing that causes a downward bias, right? What we're calling gravity here on Earth. In other words, when you drop a microphone to the ground, there's something that is causing it to go down. And I can tell you right now, guys, buoyancy and density alone do not explain the whole, downward vector thing, right? There has to be a force there, and I'm going to prove that, right? And
yeah, they
it's
play
really
a huge role. Don't get,
oh, they do. They play a huge role.
Yeah, they're huge. The downward bias is a very weak, it just sets a direction and a vector. The vector, a direction and a magnitude. That's it.
Yep.
And then the rest is taken over by, I think Ken says there's 7 different things.
Yeah, so
that are all attributed.
Yeah, as far as the modalities and stuff, and yeah, there are 7 different things that are attributed to it. But yeah, it's so, a lot of people are trying to argue that relative density disequilibrium is the only force, which I can't even believe they call it a force. It's not a force, but it's the only thing at work that is causing things to separate and go up from down. That simply isn't true. And again, it's really, really quite easy to prove. That's something that just kind of astounds me. And honestly, in that whole gravity argument, I'm surprised that the ballers haven't come up with, what I've come up with, which is the most obvious of proofs that this downward force actually exists. But before we get to that, let's go ahead and I'm going to play Zach's latest video.
Before you do, Bob, I just want to say one more thing real quick. These are laws of nature. These are, this is Gauss's law, this is Faraday's law, Ampere's law, Coulomb's law. You can't scientifically prove these with a scientific experiment. It's just like the laws of thermodynamics, all these different, it's a natural law. It cannot be, you can't step outside of the electric field or the magnetic field. The only place that there isn't an electric field would be in a vacuum, and nature abhors a vacuum. We've never found a vacuum, so this isn't something that can be tested in a scientific experiment. That's why they call it a law of nature.
Yeah, it's just something that absolutely is there, right?
Yeah,
like
it always
this,
works. Always.
right?
Yeah.
This acceleration is always there. And it's really, like I said, it's very quite easy to prove, but we'll get to that here in a few minutes. So let's get to the basis of, where this is coming from. And basically it's our position that instead of an autonomous force, right? Some other new force out there called gravity that is causing things to accelerate downward or earthward, right? Because it definitely has a specific vector, and that vector is earthward, right? We're saying that, first of all, you have to look at it from within the confines of a flat Earth model. And within the confines of a flat Earth model, it is our proposition that what we are dealing with here is we are dealing with the Earth as one plate of a giant capacitor, right? So if you know what a capacitor is, it's basically two plates that are separated by a dielectric, or usually something that is non-conductive, and then a charge is applied to each side of those conductive plates, right? And what it does is it causes the positive charge to attract to the negative charge, and the capacitor then is able to charge a huge amount of electrostatic potential. All right, notice I said electrostatic potential. So we're saying the same thing is essentially what is happening here on the flat Earth model, and that the Earth is one plate essentially, and the firmament, which, if you haven't watched some of the shows that I've done on the firmament and the incredible amount of proof that there is something there, especially specifically at about 63 miles up or 100 kilometers, you really need to get familiar with that, because there is a ton of stuff that tells us that there's absolutely something there, not to mention the fact that when you have a firmament, then all of a sudden you're not violating the second law of thermodynamics, because then we are in a closed system. We do have a container that's closed. We do have a environment for gas to press, all over the place, right? So that's just one of many, many pieces of evidence that we have that show this. So when we talk about this, first of all, take your globe Earth hats off, because this is in the context of a flat Earth model. And this is what we want to build, right? Now, there are some people that say, oh, well, we don't live on a model. Well, great. No, we don't live on a model, but models are extremely helpful in trying to demonstrate something and show somebody how you believe something is working. And in fact, models are used for damn near everything. I mean, let's face it, there isn't anything that is engineered that is not modeled first. So, you can sit there and claim all day long if you want that models, we don't live on a model, but that doesn't mean that we don't use them. And they are extremely helpful.
Yeah, it's an important tool. It is. It's an important tool to have, especially when you're trying to educate others.
Yeah, precisely. So, and also mods, by the way, I don't know where all the mods are, but I'm seeing more trolls than I would like to see. And don't just time them out, just ban them. I don't want mods here like this guy. So I hate having to do this, also moderate. No trolls allowed here. You're going to come and troll, go somewhere else. You're gone, and mods just ban them instantly. So, okay. So let's go ahead and let's play Zach's video, and this will get us on the road to where we're going to go with this today. And here we go. And let me know if you guys don't hear this for some reason.
Hello, everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala if you prefer. In this video, we will be explaining how incoherent electrostatic acceleration creates the downward vector.
Okay, now first thing is, you notice how Zach labeled it incoherent electrostatic acceleration. Now the reason for that, it's different obviously than incoherent dielectric acceleration, and the reason for that is because he is honing in on one specific modality of the luminiferous ether. Okay, and this is the modality that essentially gives us what we call gravity, right? And when I say gravity, I don't mean the kind of gravity that allegedly is tossing around planets and the Earth around sun. No, I don't mean that at all. I mean that this is the thing that gives us our acceleration towards Earth ground, because there is an absolute direction. You can say that there are There are relative directions, which is just about every direction there is, but there are two directions that are not relative, and they are up and down. And down absolutely is not a relative direction, unless, of course, you're a ball earther. Then you could say, oh, yeah, well, I'm in Australia, so my down is antipodal of your down, and so it's got to be relative. Well, that's great. But again, we are not on a ball Earth. We are not promoting a ball Earth. We are on a flat Earth. So down is earthward, period. So again, the reason Zach is singling out electrostatic acceleration is because that is the modality that gives us our downward acceleration. Let's continue on.
Gravitation, a word which many do not comprehend, is a theory that was created to explain the paths of the luminaries above and what keeps them in orbit around other bodies, including our Earth. It has been known and taught in college-level physics courses that the electric forces that hold the Earth together are 26 times stronger than the gravitational forces that are supposedly here on Earth. I will now show you a short video of former MIT physics professor Walter Lewin explain this quite clearly.
So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale,
and mind you guys, we have had criticism by other channels that say this is not mainstream thought. This is not mainstream teachings. Well, guys, this is Walter Lewin. This is Massachusetts Institute of Technology. The United States is absolutely premier technical school, right? And this guy is one of the most for decades, yeah, hands down. I mean, if you went to MIT, it's like, we're not worthy type shit, right? This is our premier school in this country, and he is one of the most famous professors that ever came down the pike, all right? So to say that this is not mainstream knowledge or this is not being taught in the mainstream, you're dead wrong, because here it is coming directly out of MIT. Let's continue.
Scale up to thousands of kilometers, it's really electric forces that hold our world together. But on a much larger scale...
Can you stop it right there for a second, Bob?
Planets and stars and the...
Yep, go ahead.
Up to thousands of kilometers. So once the ionosphere ends, and then everything now, because everything within the ionosphere is not electrically neutral. I mean, we say that the charge is neutral, but when you're in an electric field between two Gaussian surfaces that are opposite, we have the positive above, the negative below, there's going to be a little slight polarization due to electrostatic induction. It's just, this is one of those laws of nature. So up until the ionosphere, which is a theoretical conceptual concept, that's what he's talking about, thousands of kilometers. So up until you get to the edge of the ionosphere, and then free spaces after that where there is no electric field, then gravity starts. I just wanted to make that clear. That's what he's talking about.
Yep, there you go. Straight out of mainstream US MIT. Let's continue.
Galaxy, it is gravity that holds our world together. And now you may say, that's very inconsistent with what you just told us, because didn't you tell us that D cancels if you compare gravity with electricity?
Yes, but keep in mind that most objects in the universe have only a very small amount of charge per unit mass. The Earth and Mars have each a charge of about 400,000 coulombs. The gravitational force between them is therefore about 17 orders of magnitude larger than the electric force.
So even though our immediate surroundings are dominated by electric forces, including your own body for that matter, the behavior of the universe on a large scale is dictated by gravity.
And again, we absolutely disagree with that, because when we look at the universe, or when we look up there, we see it more as an electrical plasma formation of lights. Those lights form some sort of energetic grid. What precisely they're doing, I don't know. I do know that they seem to have an influence over occurrences that happen on Earth. They seem to have an influence over us, both biologically, physiologically. They can have absolutely profound influences. Full moon is a really good example of that. People seem to go completely Looney Tunes, when a full moon comes out. So again, we are amidst the stars and the planets, and those lights up there are forming a huge energetic grid that we are literally swimming in. This is our environment, right? So this is what we're trying to understand. And of course, the mainstream would like you to think that these lights are out there and they're really nothing, and they mean really nothing to us, and they don't affect us in any way because they're really so far, far, far away, when in fact they are very, very profound and influential on our very existence. So just wanted to make that clear. All right, let's continue on.
As you heard the professor state, gravity does not take place until we start talking about a moon orbiting a planet, the planet orbiting a sun, or stars orbiting the center of their galaxies. I fully agree that this is a theoretical concept that is unproven still today, and find it odd that they need ideas such as dark matter to make up over 90% of their model to explain how it is possible. Having said this, I completely understand people's reluctancy to use gravity in any kind of discussion about the place we live. At the same time, most people who have never been educated on the subject correctly believe that the force holding things in orbit and the force making things fall are one and the same, in which lies the problem. It is hard to explain how this place works when most do not know how the laws of electricity control the world around us. I will try in this video to explain how incoherent electrostatic acceleration works while using examples that can be recreated by anyone. To start out, we will take a look at Earth's electrostatic field. This is important because we, along with all the matter in this known realm, are inside of an electrostatic field. The Earth itself has a measurable negative charge compared to the air above it all across the plane. As soon as you leave the surface, there is a positive charge in the air around you that grows in electrostatic potential the further you go up towards the sky. It is a steady, gradual rise in potential, which tells us, according to the laws of electricity, that we are between two Gaussian surfaces. A Gaussian surface is simply a surface that encloses or distributes a charge.
Right. And again, those two surfaces, the Earth itself and the firmament. Okay. And again, we also know for an absolute undeniable fact that you can measure this at 100 volts per meter. And it's been measured up to 50 kilometers, which, at that, at the known measurements, according to Richard Feynman, they've measured a static potential of at least 5 million volts going up to 50 kilometers. And we know that it goes much, much higher than that. And we also know that there's a whole nother area of charge potential that's going on up there, because we can see sprites and elves, or up vertical rising lightning going up, discharging, flattening out on something that's up there. And it's interesting that it just happens to flatten out right at about 63 miles, again, where that top firmament plate is. Okay, so go ahead.
I was just going to say that something I pulled that was important from this was that constant electric field, and that in itself wouldn't be possible if we lived on a ball.
No,
it wouldn't be a constant electric field. It would, that in itself, that shows you that that we're on a level plane. I thought that was sort of slam dunk on their part.
I agree. And not only that it's even there, but it's so incredibly uniform. And it is very, very uniform. And that goes along with something that gives a very constructed feel to it, right? Again, if you understand the electrostatic potential and the gradient of that potential that exists between two capacitor plates, then you know what's going on in this flat Earth. And of course, Zach is going to demonstrate this with his Van de Graaff generator, how we can change those potentials and also that electrostatic acceleration. Now, some people have made the claim that, oh, well, if that was true, you could simply do this test from within a Faraday cage, right? And I'm not even going to mention who said that, but he's a complete idiot. But a Faraday cage is meant to block EM, electromagnetic, not electrostatic signals. I have worked in a Faraday cage, and basically what it is it's a room that allows you to be in a radio frequency silent zone, right? And radio frequencies are electromagnetic waves, all right? Not electrostatic, but electromagnetic. I think the example that this clown used was an airplane getting struck by lightning and then calling that a Faraday cage. That's not a Faraday cage. That's not what they're about. And that certainly, you cannot put a Faraday cage on the inside and block anything electrostatically. It is an EM shield, not an ES shield. So anyway, let's continue on.
If there were only one surface, the rate at which the positive potential grew would be different. Knowing that we are between two Gaussian surfaces, we can also know that certain phenomenon will take place in all matter within the electric field, or area between the two surfaces. For this topic, we will first look at polarization through electrostatic induction. Electrostatic induction is a phenomenon where the positive and negative static charges on matter are slightly separated or polarized due to the electrostatic charge of its surrounding area. If one set of the object's surroundings is positive and the other negative, the negative charge on the object will be attracted to the positive area around it, while the positive charge on the object will be attracted to the negative area on the opposite side. So here on Earth, the positive charge on our bodies is always attracted down towards the Earth, and the negative will be attracted to the air above. This phenomena creates a slight force in that downward vector, because as soon as we leave the ground, we start becoming positively charged by the air around us and are now forced towards the negative of the ground. This is electrostatic acceleration. One might think that the attraction from above and below would cancel out completely, but it is the electrostatic gradient that creates a flow from the positive above to the negative below. Think of the Earth as a flat strainer, and there is a constant flow of water from above, moving very slowly, always applying a force in a downward direction.
Okay, and one thing, this is a really great example, guys, to think of as a visualization for this downward vector, okay? And again, we can prove it. I'll get to that in a minute. But one thing that we discovered, especially when we were playing around with the fiber optic gyro, is that once we discovered and were able to confirm, beyond any doubt whatsoever, that we were in fact tracking the luminiferous ether itself, instead of Earth rotation. When we discovered that, what is happening with the luminiferous ether is it is actually spiraling, just like a tornado does, downward, earthward, from the sky down to the Earth. And as it gets closer and closer to the Earth, it starts spinning faster and faster and faster. And so what it's doing is it's exerting a pressure itself on the creation, because one of the other things that we're going to talk about is what exactly is creation, right? What exactly brings matter into form? Okay, and it is our position that essentially what's going on here is the luminiferous ether is being cymatically excited or vibrated into cymatic formations. And of course, if you guys know anything about cymatics, and this will be another part of this presentation, this is exactly what God meant, or the Bible meant, when God spoke things into creation. That's exactly what you're talking about. So again, we're working on something that's completely different from the mainstream, except for this gravity thing here, because again, I can prove this, and this works on either the flat Earth or the globe Earth model as far as this downward acceleration. There's a proof that absolutely just destroys any relative density disequilibrium nonsense that some people are pushing. But I'll get to that later. Let's continue on.
This would be considered a vector. The electrostatic potential difference getting stronger as you rise from the Earth will keep a steady pressure from above at all times until it reaches the Gaussian surface above. When we reverse the polarity of the electric field and put a negative surface above a positive one, we can reverse this electrostatic phenomenon and get things to stick to the upper plate as if it were the ground. This works with all types of matter. You can move wood, iron filings, and even human hair.
Right. Now, one other thing that I want to say also, the reason this is more prevalent in the electrostatic realm is because all things, absolutely all things, contain a static charge potential without any exception, right? Everything contains an electric static potential. Okay. And when you are talking about, magnetism, magnetism doesn't, there are certain things that magnetism doesn't affect nearly as profoundly, right? For example, you take a magnet and you can stick it on a metal plate, and all of a sudden a little 4-ounce magnet seems like it weighs 60 pounds, right? Because it's a neodymium magnet. But you have to really crank up the magnetic field to a high Gauss rate to get things like frogs, right? We've all seen the frogs that are floating in the magnetic field, but that goes into an area that it's much higher, of a Gauss rate or a magnetic field than it actually requires as far as an electrostatic field to have an influence on things. Electrostatic fields, we've seen it. It'll have an effect on metal, wood, styrofoam, hair, biomatter, you name it, paper, whatever. It has an effect on almost everything.
Yeah, electricity is also scalable. So if we took these two plates that are only about 12 inches across, they're a foot wide, and if you blew them up to be the size of the Earth, those plates are over 3,000 miles apart. And the little pieces of iron filings that I was lifting up into the air were bigger than Mount Everest. Mount Everest would be less than the width of a human hair tall.
Right. So when you scale it,
electricity is scalable.
Yeah, so, absolutely. And that's one thing I've always said. The thing about electricity and plasma physics in general is if it works on a small scale, it scales all the way up to, galactic sizes, if you will, at least theoretically. And as far as we can tell, in practicality, what works on a small scale for electricity also works on a large scale. So, we're not even going into la-la land here at all in the least, guys. This is absolutely applicable on all scales.
And when you think of magnets, they're highly polarized, whereas most materials aren't that polarized, and they're basically created that way.
Yep. Yeah, absolutely. So, okay, so let's continue on.
These forces. Believe it or not, you can even get water to bend. If the vector lines created between the two Gaussian surfaces are curved, all the matter will follow these field lines as well. In this demonstration, instead of using a flat plane, I use two circular objects as my Gaussian surfaces. You can see that as the water settles after being sloshed around by me turning the wheel on the Van de Graaff generator, it comes to rest with a curve in the surface following the electric field lines between the two spheres. This is why the ionosphere, a phenomenon that has never been created in a lab is a theory yet to be verified, but is needed to create this phenomenon here on Earth. Maxwell himself changed Ampere's law, which stated plainly that without matter, no electrostatic field can exist. Maxwell changed it with no scientific evidence, allowing it to gather magically above our heads in free space. Density and electric potential go hand in hand. The denser something is, the more electric potential it can hold. Not that I believe in the model of the atom, but even the periodic table has a distinction on the amount of electric potential there is in the different elements. In this demonstration, I have a metal button hanging from helium balloons that keep the button buoyant just above the ground. By only adding more electrostatic potential to the button, you can see it will appear heavier and force the buoyant object down along the vector lines created by the electrostatic potential difference. Without changing the density of the medium or the object, one can change the overall weight or gravitas of the object. To do an actual experiment on the topic of gravitation, this variable of electrostatic acceleration must be taken into account at all times. Now we will take a look at how different electric potentials of gases act in this electrostatic medium we live in. Gases have different electric potentials, just like all matter does. The gas molecules that can hold more potential than those gas molecules around them are theoretically more dense and will have a stronger attraction towards the negative ground below.
Okay, guys. Now, first of all, I just want to say really quick that the reason Zach included this particular segment in here is because there were some really silly claims made that electrostatic energy would not affect gas. That's just ridiculous. It not only does it affect it, it affects it profoundly.
Yeah,
there's
they
technology.
fly by it now. They're making planes that can fly that don't have any moving parts. They just use electricity.
That's right. And it just generates, and what it does is it accelerates gases and, actually acts as a propulsion method. So, when you hear people making nonsense claims like that, not to mention the fact that, you can plasmatize gases and then subject them to electrostatic fields, and it will have another profound effect. So it will affect them not only as far as an ionic wind, but as far as plasma. In other words, there is nothing, not even gases, especially not gases, that are not affected by electrostatics, period.
Yeah, they seem to actually be moved more than any other thing. They're the easiest ones to move. A gas is very easy to get to move using electricity. As where matter, I had to have the plates so close, and I can just stick a nail on my Van de Graaff generator and start cranking it, and you feel the wind blowing on your hand. You can put your hand by it, and it'll be blowing on a certain part of your hand coming off the edge of that nail. So gas molecules are very easily manipulated with electrostatic forces.
Yeah, but again, there are people out there claiming that that's not true. But again, they have no idea what they're talking about. And again, I'm not going to mention names because these guys are just too dumb for their own good. So let's continue on.
When these gases are carried along the downward vector by these electrostatic forces, the lighter gas gets displaced and becomes buoyant until it finds a place with the same electrostatic potential. This is why we have a pressure density gradient and are told the noble gases work their way up into the higher elevations and collect in layers above. We do know that when a gas loses its electric potential, it slows down so much that it turns into a liquid, like the condensation that forms on a window when it's cold outside. The gases hit the cold window and transfer their potential energy to it, trying to mediate the temperature.
Okay, now guys, the reason that we included this in here is because there are other people out there that are claiming that gases are not are not affected by a downward acceleration. While it is true that gas molecules, when you equalize from one tank to another, and you initially get that rush of gas molecules from a stored container into a vacuum, they will continue to bounce around and bounce and bounce and bounce all over the place. Eventually, the laws of conservation of momentum, laws of conservation of energy will take place, and they will not continue bouncing on forever. Eventually, they will slow, and they will succumb to these downward acceleration forces. In other words, guys, gas molecules do go down, go boom, boom. And if you know who I'm talking about there, I mean, and by the way, he's made this. If you're using this as a catchphrase, oh, gas molecules don't go down, go boom, boom. Please don't sound like a preschooler. That's you just denigrate all of us by doing that. Because they will succumb to gravitational acceleration or incoherent dielectric acceleration. They do, and it's provable. And when they do so, guys, they also typically change states. What do? They change states from a gas into a liquid. Look at the atmosphere. Look at rain. You have things going up in a gas, and then once the excitation slows down, they come back down in rain and snow. It's all part of our biosphere, right? So, oh my God.
And it's always in motion. It's always in motion. The sun is heating, certain parts, and just the temperature differences is going to create a movement of the atmosphere. The gas is releasing from the ground, coming up always. I mean, Lucas was telling me volcanoes, how much sulfur is released into the air by volcanoes every year?
Yeah, well, there's the volcanoes are going all the time, and they're releasing, multiple different elements up into the atmosphere. But the sun also,
X, a lot of sulfur X.
Mm-hmm. Yeah, but the sun's, as it goes on its daily path, it's, adding this pressure. It's adding also the heat, so it's keeping everything moving as well. And then if you have the polar opposite, the moon, well, it's doing the exact opposite of the sun in that sense. So it's keeping this fluctuation happening at all times.
Yep. All right, cool. So anyway, wanted to throw that in, and like I said, we are going to elaborate on this massively, but we can only cover so much stupidity in one video and in one meetup. But we just wanted to touch on these things. Let's go ahead and continue on and finish out this video. Here we go.
In doing so, the gases lose their electric potential and turn into a liquid. Down here near the surface, the system is very dynamic, with all the plants and animals breathing, low altitude weather patterns constantly cycling, and Earth releasing gases from the deep at all times. We will never see all the gases lose their potential and turn into a liquid anytime soon, I hope. Now we will get to the incoherent part of the phrase. It is called incoherent because it is not completely polarized, like a magnet, but only slightly on its surface through electrostatic induction. A magnet, with all of its potential stored on opposite sides, would be considered coherent. Now these forces are very weak and only apply a slight pressure along the vector they create. All other pressure mediations, such as buoyancy, atmospheric pressure, and temperature, are certainly stronger, but nonetheless, these weak electrostatic forces are ever present in the world around us, and I fear the day they may come to an end. Again, I fully understand people's reluctancy to use the word gravity when speaking of this place we live. So instead, let's call it what it really is: incoherent electrostatic acceleration. Let's teach those just finding out the nature of this world in which we live the correct way. The fact that we live in an electric realm with a static electric field you yourself can go out and measure tells us without a doubt that these well understood laws of electricity create the downward bias phenomena we witness all across the plane. Instead of using the word gravitation, I ask you to educate yourself further on incoherent electrostatic acceleration. This is Good Times for All here, signing out. As always, thanks for watching.
Awesome. Okay, so let me actually reshare my screen here. And we are going to continue on. All right, so basically we have kind of given you an idea now of, you know, where our case is coming from about where this downward vector is coming from. Now, there is a school of thought out there that is saying that simple relative density disequilibrium is something that is actually the mechanism that is causing things to go either down on a vector or up on a vector. And while it is true that things do go down on a vector and up on a vector, it is not strictly from relative density disequilibrium all on its own. There is something that actually has to initiate this force. So, you know, we've talked about the density tower, right, that has gone up in the Vomit Comet, right? And if you change the bias, right, you push over into a 0G position, the density tower all of a sudden will no longer arrange itself. It just is a scrambled mess. But if you push it over a little bit more where things actually start going up towards the top of the aircraft, what happens is the density tower reorganizes in the opposite direction. Well, I'd say that's a pretty good indicator that, you know, some sort of a bias or some sort of a downward or upward pressure has to be the mechanism which is causing this to happen. So, geez, how could we test that? How could we test how that could be done? Well, wouldn't it be cool if we could just eliminate the medium altogether, right, and not have to worry about a medium, and then see if anything chose a vector? How can we do that? Well, first of all, I want to make you guys note that when they talk about gravity, even mainstream calls it gravitational acceleration, right? It is an acceleration, not a force. So is George Musser right? You can think of a force, but it's not a force. Sure, George Musser's right. That's great, fantastic. And you know, their reason for saying that is they want you to believe in the Einstein modality of things, where space-time actually is the cause of, you know, this so-called gravitational force. But the way that we can actually measure this, and I have touched on this before, is through this instrument here. And isn't it interesting that they make an instrument to do just that, the gravimeter? Now, a lot of you will remember I was pushing this really hard several months back. And then one day, Jeranism said, you know what, I did some research on the gravimeter, and it turns out that, you know, what they've done is they've added all these filters into it, and they compensate for this, and they do that, and they add all these things that really convoluted. And, you know, I got to tell you, I have to thank Jaron for pointing that out, because he was absolutely right. And it made me look into these things very, very deeply. But what is really interesting about this is that when I started looking at the different types of gravimeter, there are multiple ways that they can actually test this downward acceleration. And the original way that they tested it was through accelerometers, right? Through a Michelson-based interferometer, and they use that as the mechanism to test the acceleration of you know, what we're calling gravity. Okay, so how do they work? The way they work is, I wonder if I should maybe talk about this first. You know what? I want to play a little small demonstration on a Michelson-Morley type of interferometer, so I can give you guys an idea of what of how they actually work here. So hang on just a second. I hate this. I really hate this screen share mechanism. Let's go share screen and Geocentricity second. Share audio. Okay. All right. So basically, I'm going to allow Malcolm Bowden to tell you basically how this Michelson interferometer works, and then I'm going to apply it to how they use it and measure accelerations in the gravimeters. Okay, so let's hit this.
Not
really
a
quick.
flat earther either. He's a geocentrist, but he's definitely not a flat earther.
Yeah, he's definitely not a flat earther. Here we go.
In 1887, Michelson and Morley carried out an experiment to check this speed of the Earth through the ether. They passed light through two long arms, one in the direction of the Earth's travel and the other at right angles to it. The light traveling in the direction of the Earth's travel should have taken longer to return than that traveling at right angles to the Earth's direction of travel. To the amazement of the scientific world, no such speed as 30 kilometers per second was detected. But they did get speeds between 1 and 10 kilometers per second. Ignoring these speeds, this experiment is always referred to as giving a null result. This shook the scientific world, and to overcome the implication that the Earth was stationary, they invented the Fitzgerald-Lorentz contraction. This claimed that the arm that was in the direction of the Earth's travel became shorter, so that the time to return was the same as in the other arm. There was absolutely no justification for such a solution. It was only invented to overcome the idea that the Earth was stationary in the ether.
Okay, guys, you know what? That was not the best example for me to use. Let me go back over to this, and I apologize for that. I should have thought that through a little bit better. But essentially, let me just kind of explain it of how it's working. All right, so in a nutshell, what's happening is you have this device right here. This is the gravimeter. And what it does is it has inside of it a laser interferometer, okay? In fact, it's very much a Sagnac, a Michelson type interferometer, all right? And what happens is it releases like a little steel ball, right? And it drops it down, I don't know, 8-10 inches, something like that. And as it's going down, it also starts an atomic clock, which is accurate to, 10 to the 9th places, some ridiculous amount of accuracy, right? And what it does is it as it measures it going down the tube, with this astounding accuracy, it is timing it, and then it is working out mathematically exactly what the rate of acceleration of that ball is. Now, the beautiful thing about this is that the tube that the ball is in a vacuum. So there is no medium, right? There is nothing that can claim a density or buoyancy variance because there's no medium. This is pure downward acceleration. And notice it always does go down, guys. I mean, no other direction will do that ever. In a vacuum, things will always go down. Absolutely no exceptions to that, because there is a bias to that. So what's happening, right, is when you take this gravimeter to different places around the Earth, or even some days on the same places on Earth, you will get different values of acceleration. Well, how is that possible if there is no medium to go through, right? There's no medium or anything like that, when all it's doing is picking up the sheer acceleration, whatever it is that is accelerating that ball from top to bottom, right? It's in a vacuum. Nothing changes inside of the instrument itself. And of course, some people will come back with a ridiculous response that, well, nature doesn't have a vacuum in it, therefore that's an invalid test. And it's like, that's ridiculous. And here's why it's ridiculous. Because when we eliminate something, when we put specificity to our tests where we can eliminate certain variables, it actually acts to serve us as a tool, right? If we can get rid of this buoyant and dense, density gradient, and just measure purely through the vacuum, the drop rate through the vacuum itself, then we get a pure, unaffected outcome every single time, right? And the interesting thing is around the Earth, things fall at different rates. Now, why would that be? Well, we actually have a great explanation for that, why that would be. And we actually also have some experiments that are going to prove it, okay? But this device right here crushes the relative density disequilibrium argument, absolutely crushes it, because there is nothing that you can claim here where anything is going from a less dense to more dense medium. It's in a vacuum, it's all the same medium, and yet there is still a downward acceleration, and that downward acceleration does change from place to place, and even sometimes in the same place, right?
So Bob, does that, at the risk of sounding stupid, and I'm feeling pretty stupid at the moment, but does when you say everything goes down, do you mean gases as well inside this device?
Even gases will, yes, because if you have helium, and helium is the least dense gas we know, right?
Mm-hmm.
But even helium has to be, if it's going to rise, it has to float up on something, right? Well, if there's nothing to float up on, then what's it going to do? It's going to sit on the bottom.
Sit on the bottom. That's really interesting. I didn't know that. And do they have these sort of devices, bigger devices than these? That, because I'm just thinking about Zach's balls.
Yeah, that's what I was going to get to. That was one of our experiments that we're coming up with. Yes, in fact, they have a million different kinds of these. Not only do they have the laser interferometer type, but they have them on springs. They have them for specific gravitational forces, and otherwise. Let me play this really quick. Let me get another one here. Hang on. And let's play this really quick. This is just a really quick blurb on it that I thought was kind of effective.
A gravimeter is an instrument used in gravimetry for measuring the local gravitational field of the Earth. A gravimeter is a type of accelerometer, specialized for measuring the constant downward acceleration of gravity, which varies by about 0.5% over the surface of the Earth. Though the essential principle of design is the same as in other accelerometers, gravimeters are typically designed to be much more sensitive in order to measure very tiny fractional changes within the Earth's gravity of 1 gram, caused by nearby geologic structures or the shape of the Earth, and by temporal tidal variations.
Okay, now first of all, let me say that because of the fact that we are dealing with such a very, very extremely sensitive instrument, yes, there are things that can affect it very profoundly. And that's why what you want to do is you want to take as many samples as possible so that you get out of any noise of the samples that you're taking, or false readings caused by vibrations or anything like that, right? So basically the answer to that is to simply do more tests, take longer duration tests, and then average them out. But the bottom line is we still have a very specific acceleration that is always there. And again, you can eliminate this acceleration by going up in a vomit comet and, just like I said, pushing the nose over a little bit more and causing that acceleration to go up towards the top of the airplane. And then when that happens, the density tower reorganize in a different direction. Well, that right there should also be proof positive for anybody, that it requires that slight bias for the density towers to form into their individual gradients, right?
That was the clincher. That was the clincher for me.
Yeah, that's absolutely a fact, right? And we're going to cover this a whole lot more, right?
Well, yeah, you're not altering the medium in the density. The density tower is a contained system itself. So the mediums of the density tower aren't really being, altered in any way except for that difference in, like you said, nosing the plane down and getting that G-force to be inverted.
Yeah, that's just a way to kind of quasi eliminate the downward force. In other words, you're basically equalizing it, right? You're neutralizing that downward force by doing that. But, there are several different kinds of gravimeters. And like I said, thank you, Jaron, for putting me onto this because, otherwise I probably would have never looked into this. And I'm going to show you guys something in a minute that's absolutely bizarre. So you have like absolute gravimeters, which measure, right in one very specific place, how much that acceleration is. And then you have relative gravimeters that compare one specific place to other specific places, right? And then form an overall type of acceleration, right? And beyond that, you can also use the density. And this is cool thing about this, guys, is you can also use something that is called specific gravity, right? As a way to measure relative density, right? So you've got your relative disequilibrium that you talk about. And it's interesting because some people would like to kind of reinvent the wheel and say that, they discovered this relative density disequilibrium, but in fact, it's been known for a long, long time. Here we have the Wikipedia page on relative density or specific gravity, okay? So even the mainstream are fully aware that you can do these specific gravity tests, but they also know that without that 9.8 meters per second squared downward acceleration, that the relative densities and the relative density disequilibrium will not and cannot take place. It's as simple as that, okay? So again, it all comes back to the gravimeters, guys. This is a technology. These things are expensive as hell. They use laser interferometry. And if you are not familiar with laser interferometry by now, after as long a time as, you've been listening to me on Globebusters, well, I don't know what to say, but they are one of the most precise measurement techniques we have, bar none, today.
Yeah, they're super expensive. I was looking into these for the drop test, and I was like, yep, that's out of the question. No way.
Yeah, exactly. So Bill Wool says, Bob, what about the difference in speed of electricity going through the electronics affected by temperature? Well, first of all, the speed of electricity is, when you're going through conductors, you drop down to about 0.6 C, and then when you have heat, that will actually further drop the speed of electricity, but I don't know what that has to do with, this argument for gravity, Bill, so maybe you can elaborate a little bit on that. But anyway, all right, so these gravimeters, guys, this is a piece of technology, and honestly, the more I think about it, I think I would love to get one of these, to put in for one of these on the TV show, so that not only can we show that this gravitational downward acceleration absolutely exists and do tests with it, for those flat earthers out there that seem to not be able to get their head around the idea that this downward acceleration is absolutely there, right? But wouldn't it be great if we could actually carry out the tests with this and show them exactly how it's done? Now, I do have some videos of people doing tests with these, and I don't want to watch those right now, but these pages are all part of the homework assignment that are in the show description that I want people to understand before you come to me and you start saying, well, relative disequilibrium is all you need, because that simply is not true. Without the downward acceleration, guys, I don't know how many times I have to say this, without that downward accelerations, relative density disequilibrium will not work, period. Okay.
No, the denser object has to know which way to go. There has to be, that direction for the denser object to go this way and displace less dense objects and make them rise, become buoyant.
That's right. To displace it, there has to be a downward force. Otherwise, it can't displace. Otherwise, there's no energy there to force things to go up in the opposite direction. You can't just have a displacement without a force behind it. And I hate to use the word force, and I don't even want to use the word force, but let's face it, to move something, we're taught pretty much that you've got to push it or apply a force on it. Well, without that downward force, pushing down or accelerating down, then nothing's going to accelerate up either. All right. Or rearrange.
Yeah, think of it, put yourself 1,000 feet up in the air. Okay. And you have a bunch of tennis balls. There's only one direction you're going to throw it, and it will always keep accelerating in that direction. You throw it sideways, it's going to go sideways for a little bit, but then eventually it's going to start going in that downward vector. You throw it up, it's going to go up a little bit, and then it's going to come back down in the downward vector. The only direction you throw it is down, and it will accelerate and accelerate and accelerate faster than you started throwing it. That's the only direction matter does that in.
So would you say that the density and buoyancy side of the equation is what causes the motion, causes a change, and it's the downward bias is the direction in which the change or the motion occurs, or upward bias? There is an upward bias with a gas that's lighter than air? Yeah.
Well, the only reason that there would be an upward bias is, first of all, in order for things to go up, like gases, helium, they have to displace something downward, right? So in other words, in order to get something to go up in that tube, you have to push down.
And
right?
That's shown with the Smarter Everyday experiment where he had the helium balloon in the car, and he accelerated and it went forward. Is that right? Because all the heavier air went back.
Exactly. The heavier went back. Raichi 00000 also, showed that. And yeah, that's right. And that's counterintuitive at first until you realize that, all the heavier air is pushing that lighter gas forward. But that's the whole thing. There has to be something there, some sort of force that is active there to cause the displacement, right? You can't just have things willy-nilly, dislodge themselves, and or you can do like Sleeping Warrior with his stupid pouring salt in. He doesn't seem to understand that when he poured salt in, he changed the downward vector. I mean, we all did that freaking experiment in school in, I think, second grade, and it was basically to understand how buoyancy worked. But again, without that initial force there, it simply cannot work. You cannot generate a force out of nothing. It has to have something there already. And then, as Ken Wheeler says, everything being about pressure mediation, the whole universe is about pressure mediation. Well, then when you change the pressure on the downward vector, then things can go up, right?
And so when a plane reaches that parabola, the top of its parabola, it's effectively taking out the downward force, and
it's equalizing it. Yeah, essentially it's neutralizing it.
Yeah, and what we observe is that the density tower just mixes. There's no order to it. Okay.
Nope, none at all. And we've seen that demonstration. And again, and then all he had to do is just keep pushing it a little bit further over, to now the bias now is upward instead of downwards. And then all of a sudden that density tower, bada bing, bada bing, bada bing, went and reorganized itself, except this time in the opposite direction, with the heaviest liquids, the most dense liquids, being at the top. Interesting, right?
Because you've replaced the existing downward bias
with an upward bias.
Yeah,
that's exactly right. And yet when that airplane turns over again, well, that upward bias goes away, and the downward bias, even if you're in straight and level flight, still exists, and it always does. It's always there. And this is the downward bias that they call, or downward acceleration, that they're saying is the same quote unquote gravity that allows things to orbit in space. Now, the problem that I have with this is, if I wouldn't have such a big problem with it, if making this assertion just didn't point blank make flat earthers sound stupid, right? I mean, talk about a good way to kill a discussion, especially with an academic, is to walk up with them all cocksure that you just know without a doubt that gravity doesn't exist. And it's like, well, yeah, you have to first of all define that term about what gravity is. They're calling it an acceleration. And in that term, the acceleration does exist, okay? But if you want to actually enter into the discussion realm of this, especially with ballers and talk to scientists, you have to take it from that and this basic downward acceleration. And then it's really not too hard to disprove the fact that there is no gravitational field out there that holds planets in orbits or continuously following around the sun. That's how we should be addressing this, right? Not walking up like complete morons and denying, gravity as they understand it, and even how they define it, a downward acceleration exists, because it simply does. And again, the mechanism is different. We totally disagree with that. And that's the thing that really makes this difficult to argue about, right? Because we've got several different things at play here that are confusing people, right? Well, you've got an acceleration. Well, you have a downward force. You have things falling around objects. You have density and buoyancy. And then you have all of a sudden these natural forces that we see that are real, that are applied and very real here on Earth, that NASA is telling us that this is what's causing the ISS to fall around the Earth, which we know is a lie. It's what's causing the Earth to fall around the sun, which we know is a lie. It's what's causing Halley's Comet to come back every 80 years and somehow just miss the sun, every time it comes back, which we know is a goddamn lie. All right. So this is where we should be arguing this with the ballers, right? Because there is no gravitational field present. There is an acceleration, there is no field. They tell us that it is the moon's gravitational field, which does not exist, that causes the tides, right? Well, that's not true, because there is no correlation between the moon's position really and the tides. In fact,
that is
pretty
the
easy.
Worst thing. I mean, that was just dumb of them. Why would they do that? There's no correlation at all. It's just a made-up fairy tale.
Because they knew we'd buy it. That's why they knew we'd buy it.
Yeah, true.
But I have to put my hands up and say that I was definitely one in the early days of discovering flat Earth. I was definitely one of those morons going around saying gravity didn't exist. But after observing your discussions and everyone's input and doing my own research again, I have to say I've definitely changed my mind on that front.
That's right. That downward bias, that downward acceleration is the external agent that's acting upon it, that puts it out of disequilibrium. That is the external agent.
I just hated the word gravity. It just came so loaded and so it's so weaponized that I'm glad we've replaced it with something that everyone can understand, of course. Incoherent.
Yeah. And honestly, that's going to be kind of a prerequisite, guys. If you are going to come into this discussion and and say that this downward acceleration doesn't exist, then you're going to have to tell me exactly what it is that we're seeing happen with this gravimeter. And I guarantee you, if you try and explain what's happening in that gravimeter in terms of density and buoyancy, you are going to fall on your face like there's no tomorrow, because it simply cannot be explained in terms of density of gravity. Now, what's the difference? The difference is, we're saying that downward acceleration is a mode, it's a modality of the luminiferous ether. And there are a lot of physicists that are actually on board with this. In fact, it was my friend who is a PhD electrical engineer professor in Europe at a very prestigious university, who is a flat earther, who has brought us to this, revelation that this is what's really going on. Well, him and Ken Wheeler, but I mean, you would not believe how many mainstream academics are behind this idea, because I mean, you cannot deny the downward acceleration. It's there, point blank. Okay. And like I said, if you're going to come into this discussion, then the first thing you're going to have to do is debunk the gravimeter. Good luck with that. Okay. So, all right. So let's go on to, let's see. Where was I? But yeah, I just thought this was great. So my wife, Cami, worked in gemology, and she used different fluids and gases and stuff like that to determine specific gravity of things, right? And I find it amazing that you can actually determine these specific. Wow, somebody just popped in and popped out. Who was that? Oh, we lost. We lost John. I'll pop back in, John. I'll put you back in. Anyway, it's funny because she uses these fluids to actually determine specific gravity. And isn't it funny that they call relative density or specific gravity? So they're fully aware of this, right? So one of the methodologies that they use is that. That's just funny as hell, I think. But anyway, all right, so let's go on. And just waiting for John to come back in. And by the way, guys, also, one of the things that I put in there is the Autograv CG5 operation manual that tells you exactly all the modalities and its operational theory and how it works. So, feel free to use that as a reference in your attempts to debunk it, because I doubt you're going to do it. This is something, like I said, this is technology that has been in use for hundreds of years. And again, we do all of our calculations, all of our ballistics calculations that are, that are applicable to anything with gravity based on this, right? This downward acceleration, it's all done on this. It's something that is part of science and is something that is simply not debunkable.
They're laws. These are laws.
These are laws.
And it's something you can't, do a scientific experiment and verify. That's why they're considered the laws of nature. They just happen every time. You don't step outside of them to test it. You can't. So here's how it is. They just work every time. No matter where you are, what you're doing, you can do these different tests and observations, and they're always the same the world over.
Yep. Okay, cool. So what now I want to do is I want to play an older video of Zach's that started out with asking the question, is gravity incoherent magnetism? And again, it can be viewed that way, even though we've come to realize, I think, that the electrostatic description is much better. And so, but it was much easier to demonstrate with the magnets, okay? But the point is you can do the same thing with batteries, right, that you can do with magnets. You can put a bunch of batteries in an incoherent configuration, and it will do essentially the same thing that putting magnets in an incoherent configuration. So you need to understand, first of all, what the difference between coherency and incoherency is, okay? So I'm going to play that, and I'm going to share this screen. Wow, do we have two of these?
Yeah, with the induction we're talking about, the incoherent induction, it happens on all matter, even gases. It just polarizes them slightly, not fully like a magnet. So you have to think of all matter as a bunch of little magnets, a bunch of little polarized things. Solids, liquids, gases, they all have these little poles on them because of that induction of being in the electrostatic field.
I gotta love this comment by a man like me. Oh, I see. Bob is attempting to save jobs as a flat earther. There are laws of man that aren't correct. Hey, nobody's disputing that, a man like me. But where does that even come from? I'm attempting to save jobs as a flat earther. That's just ridiculous. And this is what I say by this is all trolls bring to the table is bullshit, like what a man like me just said. Absolutely non sequitur nonsense that makes no sense whatsoever. And there's John. Okay, you back, John? Hello, John.
Yeah, he's
Yeah, I
slow
am.
with the
Something.
mute button sometimes.
Oh, okay.
Something catastrophic just happened. That yeah, I'm back.
Okay, cool. All right, so we're going to go ahead and play this incoherent magnetism video and then talk about that a little bit. And then we're going to move on to some of Ken Wheeler's theories on this. So let's go ahead and play that. Here we go.
Hello, everybody out there in YouTube land. This is Good Times for All. There's Zachary Zabala here if you prefer. In this video, we will be taking a look at the difference between coherent versus incoherent magnetism. We will again start with some quotes from Ken Wheeler.
Everything is electrical. The only thing that actually defines a magnet is field coherency. Before this is magnetic attraction. That which we call magnetic attraction, is it something autonomous from gravity? No, it's not. The only thing that defines or differentiates out the two is field coherency. Something separate and autonomous. Well, here's gravity here, and here's electricity here. Here's magnetism. No, all that shit is the same crap. Like ice, water, and steam. They're not different things. Right now, by any definition of the term, and the force required to move this object, 50 pounds. Wow, that's over a piece of metal. You know, it still weighs 4 ounces if you put it over the dirt or, wood. Yeah, do you know why? Because then we only have one object that has field coherence. I'm not able to induce induction. I'm not able to induce field coherence in a piece of wood or the dirt.
As you heard Ken Wheeler state, everything is electrical. Not only is it all electrical.
We not only heard Ken Wheeler state that, but we also heard Walter Lewin of MIT say the exact same thing.
Mm-hmm.
And that includes gravity. Let's continue.
Cool. But he adamantly shouts that magnetism, gravity, and electricity are all the same thing. The part we will focus this video on is the quote where he states the only difference between magnetism and gravity is field coherency. Instead of trying to tell you what he means, I will show you with a few demonstrations. First, we will take a look at two coherent objects and how they interact with each other. Here we have two cylinder magnets with the north poles of the magnets painted red. As you can see, when I try to place the red ends near each other, the other magnet tries to flip around to align with the non-painted end. This is because both objects are coherent, so the attraction and repulsion are both present. It pushes away when the poles are the same, and attracts when reversed. Now we will take a look at how multiple magnets, when not aligned, become incoherent. First, we will observe the magnetic field when the magnets are all lined up and coherent. As you can see, the more magnets we align pole to pole, the stronger the magnetic field gets. However, this is the complete opposite when the poles are not aligned. As you can see, the more magnets we add to our incoherent mass, the weaker the magnetic field gets. Now let's take a look at how a coherent object, the cylinder magnet, interacts with the large incoherent mass of magnets and ball bearings. As you can see, the red pole of the magnet is attracted to the mass.
Yes, and again, just like gravity, this incoherency factor is always attractive. It's never repulsive. It's always, always, always attractive. So we can draw these absolute direct analogs to this incoherent magnetic model And, you know, the relative density disequilibrium argument falls way short once again. So let's continue.
So we might assume that the bare pole of the magnet would repel. Yet this is not the case. As I flip the magnet over, the bare end is also attracted to the mass. So how does this relate to what we are calling gravity? Like gravity, incoherent magnetism is an attractive-only force. No matter which pole of the magnet is placed near it, the incoherent magnetic field is always attracted and never repelled. All matter is made up of charged particles, and like magnets, these particles have poles. The Earth and everything on it is ultimately a huge mass of charged particles. This is why everything is attracted towards the Earth. There are a few apparent exceptions to this rule, like helium, balloons, and rain clouds, and we will cover this in another video. In closing, the Earth attracts everything to it by virtue of its incoherent electromagnetic field, and this is why we find a very weak bias between up and down, and ultimately what we call gravity.
All right, that's awesome. So there's a comment in the chat from SoloCat1980, and he says a pushing force being emitted from God could explain downward acceleration. Then things could get sorted out by their density and buoyancy within that downward force from above. And you know, I can't exactly disagree with that, SoloCat, and here's why. Because we're saying it is an electrostatic. What is the prefix to electrostatic or electricity? It's L. What is L? L is God, right? Very interesting.
Yeah, it's yeah, I have no idea what is creating these forces, you know. That's why they're kind of laws. We don't know. But
I think
they're
we know
there.
a guy that does.
I wouldn't say that. I'm working on it. Yeah.
Well, we're working on it. That's the whole thing. We're working on it. And, you know, all we're saying is that to deny something that is clearly there is foolhardy. It really is. And, you know, I just don't understand this other camp that is saying that no other external force is necessary when it clearly and absolutely is. It defies all laws of physics for it not to be. You cannot simply say, you know, when you pour salt into something, you are adding, yeah, granted, you're adding that force, but you're also changing the conditions of what's going on in there, right?
You're changing the force from the egg now being what was being affected most by the force to now the water, which is being most affected because it has more density now.
I know.
So it can hold more electric potential. Therefore, it's going to be attracted to the Earth more than the egg. It's that simple. The force is still there. It's just being applied to the water now because it's more dense.
And honestly, applying a second grade experiment, and let's face it, we all did that experiment in the second grade, guys, right? Did we not? Second grade, we poured the salt in the glass of the water and made the egg float and went, hey, that's cool, buoyancy. But now we have, you know, geniuses trying to say that this is in fact what's taking place of gravity. And I just cannot even tell you how stupid that is. And anybody that goes and tries to engage in any scientific discussion with any scientist with that argument will be met with absolute disdain. We can beat them on their own terms, guys. We don't have to create fiction. It's just, this is just crazy that anybody would even want to invent something like this that is pure fantasy and disavow forces that are clearly there and that we measure with the gravimeter. You know, it's like, come on, we can beat them on their own argument because we can show these fields are not there.
They might say, you know, well, Neil deGrasse Tyson is saying that. Who cares what Neil deGrasse Tyson says? He's a failed actor. He is not some type of physicist, you know, teaching any. He is an astrophysicist, a theoretical astrophysicist. You know, when they asked him what the curve formula was, he was, what, the gravity drop rate? He had no idea what they were talking about. Who cares what that man says? I'd rather, talk with people like Walter Lewin about this. The people that are actually out there educating our youth. They're the ones I'd like to reach.
And guys, not all science is wrong. Not all of the scientific establishment has it wrong. Granted, they have some things misinterpreted, but if there's one thing that they absolutely have right, is they have mastered the calculations and the behavior of so-called gravity. But where it goes wrong is when they try to take it beyond our so-called solar system or beyond our Earth. That is pure speculation, it's pure fantasy, and none of it can be proved. But here on the plane, it can absolutely be proved. And, that's where we need to meet them. Now, you guys, if you guys remember, I did several shows on LIGO, right? And what was LIGO? LIGO was supposedly the two neutron stars that collided something like 350 or 400 million light years away, right? A long time ago in a galaxy far, far away, right? And as a result of that, supposedly they sent this gravitational wave, right? What the hell is that? There's no such thing as a gravitational wave, but this gravitational wave came all the way here to Earth, and it cut across the LIGO facilities, which then effectively shortened these 4-kilometer long tubes by the width of a thousandth of a proton, and then
but they can't measure the effect of the moon's gravitational wave.
Exactly, because there is no gravitational wave. That's why they have to make this shit up going all the way out there. And not only that, the funny thing about it is when you look at the Michelson-Morley apparatus, it is the LIGO facility. They're identical in their layout, absolutely identical. And isn't it funny that they claimed that Michelson-Morley didn't work because of the Lorentz contraction, right? I always have a problem with that. I don't know why, but yet it doesn't seem to have a problem with LIGO. Why wouldn't LIGO have the problem with the Lorentz contraction? I mean, they are always stumbling all over their feet. Guys, this is an argument we can beat them at, but my God, we cannot come across like utter bambling morons saying that this force is not there or acceleration is not there. See, even I do it. I keep saying force. And like I said, only because that, in my mind, you got to have a force.
It's going to be a hard one to change. Yeah.
It is.
Do we have a definition for force that we can agree on or not?
Oh, I don't know. Let's look one up here. I forgot what screen I'm on. I think that one. Yeah, I am.
Yeah, I had too many screens open that I crashed out, I'm afraid. But I did have a definition of force, but I'm not even going to try and open a screen again.
Okay, physical power, strength possessed by a living being, strength or power exerted upon an object. That would probably be good, but again, and this was what makes it really difficult. The force can cause the acceleration, but they're not the same thing. The force is force and acceleration is acceleration. It's like if I exert a force on the back of my car, put it in neutral, and push it, the car is going to accelerate, right? But it's not the force. So I don't know.
Yeah, that's what is possibly where we're having sort of trouble meeting heads. Is
you can
even.
Sorry, John.
No, carry on.
I was just going to say you can change the medium, but what you're really doing is changing which piece of matter is being affected by the force more, or the acceleration. You know what I mean? It's when you make the water more dense than the egg, it now is being affected more because of its electric potential than the egg was when the water. The egg was more dense at first.
Before they put the salt in.
So the acceleration was
because you're manipulating the medium.
Yeah. So now you make the medium more dense. Well, now that it's more dense than the egg, the force is now being applied to the water medium now more. It has more electric potential stored up in it, so it is more attracted to the ground.
Well, acceleration is Well, acceleration is just an increase of force, isn't it? It's constantly
Yeah.
increasing the force.
Yeah, to have an acceleration, a force is required. I don't know. You know, these are those axioms of physics.
We need answers on the postcard. What's your definition of force?
Yeah, exactly. So, well, so this is something else I want to show here. Whoopsie. Let me get this really
Can we
quick.
get away with just calling force a pressure mediation? That's what a force is.
I think that's probably a good definition until somebody comes up with a better one.
Or
I'm down for that.
Pressure differential.
Pressure differential. Well, I don't know if that would constitute a force. No, because it's not actually acting. It's just showing. It's defining a differential.
Yeah, it's
I don't
more
know.
of a measurement. That differential is more of a measurement, I'd say.
Yeah, let's turn it over to the audience and let them, because obviously we need to make up some new terms, because we've got to get rid of what the ballers have polluted, gravity with, and make up some new terms. That's why I think that the incoherent electrostatic acceleration is a good thing to replace gravity, right? I think that's a great thing.
Probably better than dropity or something.
Yeah, exactly. Much better than dropity. Yeah, that I like. Who was that? DeMar.
Yeah, and I didn't. It's not like I came up with this. Electrostatic acceleration has always been a thing for probably a couple hundred years now. It's not like I invented electrostatic acceleration. That's how they supposedly move their little particles around in an accelerator.
Yep.
They're big giant accelerator tubes. It's nothing new.
One other thing that goes along with this luminiferous ether, the physics of the ether, is a direct contradiction to the notion that the mainstream has put forward that all objects fall at precisely the same speed of 9.8 meters per second squared. We already have preliminary evidence that that is not true. And that comes to us in the form of a small drop tower. You guys have probably seen it. It's a very short video. I don't know, maybe 20 seconds long, something like that pops up 8 or 10 different elements, and they pop up all at the same time, and then they all fall at very distinctly different fall rates, right? So we also have this little thing here, which you guys may be familiar with a Lockheed engineer by the name of Boyd Bushman. And Boyd Bushman basically took a couple of neodymium magnets and he put them inside of containers, and then they were basically identical, and he made them weigh the same and everything. And he dropped them over the side of a building and had people catch them. And, every single time that he did this, the construct that did not have the neodymium magnets in it always got to the ground first. The ones with the neodymium magnets in it always seemed to fall slower at a much slower rate. Now, this makes sense because, again, if we're talking of incoherent dielectric acceleration, and this is in fact a modality of the ether, right? That means that the gravitational mode is going to change, right? So we already have the apparatus made. We're just looking for a place to actually run this experiment. And I think that this in and of itself is going to be another death blow to the mainstream gravitational model, as well as proving the fact that it is actually an acceleration. So let's listen to Boyd Bushman for a minute, and then we're going to show you what we have actually constructed to do this test ourselves. Any comments before we go, Zach?
No, I want to get it done. If you know a place that isn't, a metal building, we're trying to find something either brick or made out of wood that's 100 feet tall that we can go up into and drop these things from.
Yeah,
I thought it would
awesome.
be easier to find before I started this venture. But yeah, it's especially with all the nonsense going on now. I wanted to do it inside of a hotel, like in an atrium style hotel.
Yeah, like a Embassy Suites. That would be awesome with the atriums inside. Okay, so let's go ahead and play this, and Boyd Bushman's going to tell you what he found out. Now, some people have done this and have claimed the same results. Others are saying, no, that was BS. It didn't work. This, of course, is why we want to do it ourselves, because in order to fit in with our theory, then the fall rate has to be different, at least the way we're looking at it. But we could be wrong, but that's why we test things, right? So let's listen to what Boyd Bushman has to say. And he is a former Lockheed Martin Skunk Works engineer. Let's go.
About here if you prefer. In this video, I would like to start a GoFundMe to recreate.
Okay, we don't need the GoFundMe, or we already have it ready to go. Let me skip forward.
That part's all done, taken care of already, folks.
Yep, let's skip forward.
The test done in 96, and he made a discovery. And it has a lot to do with magnetism and gravity, and you can even hear him near the beginning here. Listen, he's going to call gravity cousins with magnetism. Kind of like Ken Wheeler states, they're all the same thing.
A lot of people are doing nothing more than getting huge quantities of mass and see if they can get a gravity wave to cause things to move. Mm-hmm. Well, that isn't what we're talking about at all. So I wondered if gravity could be related to its cousin magnetism. Mm-hmm. And so I found that when I take two magnets together, I have some neodymiums around here that I'm actually afraid of. They can danger you. Mm-hmm. But anyhow, you take a magnet, you go to put them together and they go clunk, right? Mm-hmm. But you take one of them, move it around, and all of a sudden it doesn't want to go right. The repulsive. So I got I ordered one at $5,000 a piece. Wow. with a 1/4 inch hole through between both of them, and I put a brass.
Now, don't get too scared. $5,000 a piece. That's Lockheed Martin money. So that's more like $50, $100. No, I'm sure they were probably more expensive back then, 25 years ago, 24 years ago. But anyway, I'll let him continue.
Bolt, and I tighten them down.
A brass bolt.
Forcing them together. Mm-hmm. And then I put them together in a thing that looks kind of like a rock. Mm-hmm. Okay, and then I got another one that didn't have magnets in it. Mm-hmm. And Galileo, in all his endeavors, he went
okay, blah, 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 blah. Galileo dropping things, and they hit at the same time. They show the astronauts, blah, 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 dropping the feather and the thing on the moon. We'll let him continue now.
One by the side of escalators and elevators. Oh, wow. And I got 9 guys that were not educated and didn't have pre opinions on anything. Mm-hmm. And I dropped my 2 rocks. Mm-hmm. And I said, what I would like you to do is, I told them what I'd like you to do is I would like you to take whichever one arrives first, get it in your hand. When I come down the elevator, hand it to me. Mm-hmm. Now, they looked identical, except for...
So and nobody knew it was inside?
No, absolutely not. Mm-hmm. All the 9 times that I tested it, it's as though the one with the opposing magnet field extending out 3 feet on each side. I actually measured
how big the field is.
How big the field was. And on each side of one rock, I had a total of 6 feet. At any rate, the other rock arrived first.
Which one arrived first?
The one that had no magnetic field in it.
So by putting a positive pole up against a positive pole and forcing them together, he found out that this does something to create it to interact with the magnetic field and slow its descent. Now listen to what this young gentleman over here says.
You're able to cancel out gravity to a certain degree. You are able to cancel,
precisely,
reduce the mass gravity effect.
Precisely.
By opposing fields.
Isn't that nice? You bet. And got 9 signatures, and I always get,
You did that at Lockheed. What year is this?
Oh, at least 8 years ago.
This is the actual document of Boyd's where he proved that by altering.
Now, I don't know about you guys, but Boyd doesn't exactly strike me as a liar. But again, this is why we want to test it ourselves and find out. So what Zach has done, we went ahead and we bought the neodymium magnets, and we got them and then bolted them together. And I think we have some video of it here. And here's Zach actually.
That was scary.
Yeah, I'll bet. Yeah, that thing had to be scary because you had to put a couple 100 pounds of force to push them together.
Yeah, they were 200-pound magnets. They did not want to go together. Yeah.
No doubt.
I had a big piece of wood in between me. I'm wearing those big, thick gloves, leather gloves, just in case they exploded.
You double wing nutted it?
Yeah, yeah.
Yeah, believe me,
And then
there
wrapped
is
them
a
in rubber
lot.
bands.
Yep, there's a lot of force pushing out on those things, man. And it literally, it would be explosive if those things came apart like that with the power behind those neodymiums. And if anybody's ever played with neodymiums, you know that they can smash your finger to a pulp instantly just by getting attracted to each other. So you have to be really, really careful with them.
Yeah, those
So,
ones were sitting like what, at least 3-4 feet apart up on the mantle at the house in Denver. And out of nowhere, they just whoop and slammed together and broke into a bunch of little pieces.
yeah.
Remember those 2 pillar magnets? Yeah.
That's bizarre as to why they would just suddenly do that.
I know. I
10
can't.
minutes later, or 10 minutes earlier, they didn't. But I remember you doing
make
this.
it out in my head. Yeah.
And then when you finally got it together, you threw the wood aside and picked it up and walked around with it. And it was like, holy shit, what the hell are you doing?
Yeah, that was totally cool. So then what he did after that is after we got them forced together, then you took and we put them inside of these little round balls. And the other one you put what? Just steel, or what'd you put in the other one for the dead weight?
Quarters.
Quarters. Oh wow, there's probably a small fortune in there in quarters.
Yeah.
So basically banded them all up, and the reason for that, of course, guys, is so that aerodynamically these things would be identical, and also weight wise they would be identical, right? We have to make them as, and right down, you got them right down to the 1/10 of a gram nuts on, right?
Yeah. Yeah. I should weigh them now. I'm going to do that here and see if they all weigh the same still.
That would be really interesting because you made these in Colorado, didn't you?
Yeah, this was a while ago.
And now you're in North Carolina, so that's a fair old pressure differential there.
Yeah, South Carolina, yeah, because we're at 800 feet here, but that is atmospheric pressure. But yeah, definitely, there's a difference. So anyway, so we've got these, and then they go inside of these kind of sphere containers. Which, did you put those on here?
I don't know if I showed it on this one. I think that's the next video. Showed how what I used to fill them, and yeah, because I got a lot of great ideas. The way I was going to do it right at first, if I would have just tried to do it and go out and do it by myself, it would have been a mess. I got so many great ideas from different people on how to fill it and how to get the weight just right and this and that.
Yeah, and so here they are, and you're actually weighing them so that they're identical weight. And you know what's really weird about these guys? This is a complete trip. You hold one in one hand and the other in the other hand, and if you like move them up and down, and it is so weird because the one with the magnets in it feels like it has this really weird dampening going on. It's just absolutely bizarre.
I so want to feel that. It's almost worth getting these magnets itself just to feel that.
Yeah, it's cool. And Ken Wheeler did a demonstration. Of course, that's what got us into it. Ken Wheeler's like doing a demonstration on it, going, you guys, obviously you can't feel this, but you gotta, if you did, this is the strangest feeling because you can literally feel a dampening of it coming down. It doesn't accelerate the same. It just doesn't, it's
but
crazy.
You get that with the gyroscope as well, don't you? When you move that around, it's a very odd sort of feeling.
I love taking that to the festivals and conferences and just watching. It's like children of all ages. If you've never felt a gyroscope and I get to see you for the first time, that's like one of the greatest joys because your face lights up like you're a child again. You're just like, oh my goodness, what's going on here? It really is that much of a difference.
Does the one with the magnet in it, does it attract magnets or metal to it?
Oh yeah, they both do. Because I have 2 of them, one with the south facing out and one with north facing out.
And is it a violent attraction, or is it, would you say, an
Not
incoherent?
really.
So would you say that you forcing them together has created incoherency?
Yes,
Okay.
absolutely.
Yeah, yeah, absolutely. That's because you can, and that's another thing. It's almost the same feeling that you get when you force them together that you feel when you kind of drop them with them in your hand. You feel the slowing down of it that's abnormal when you're, like if it was a normal ball, if you've thrown a normal ball up in the air and dropped it in your hand and throw it up. I mean, there's the only way to describe it is it's a dampened feeling. That's
Yeah, I didn't tell. We were over at Jack's during Flattoberfest shooting guns, and one of the guys there, I gave it to him both balls, and I didn't say anything. I was like, "Give those a toss up and catch them, and tell me if there's any difference." And the one with the magnets in it, he didn't even catch it. I don't know if it was that different, but yeah, he totally missed it. The other one he threw up and caught fine, and this one he threw up and he didn't. That was the only time I've seen that so far, but.
What, he missed it as in he dropped it or what?
Yeah, he did not catch it. He dropped it.
That's weird. Okay.
Because you're sort of creating a monopole, aren't you? By facing them in and just suppressing one side of the magnet.
Yeah. Exactly. And yet I hate to use the term monopole because I'm not so sure I believe in such a thing, although there is some compelling and interesting evidence that people have come up with, but jury's still out on that for me.
Oh, no, I'm not saying, there's such thing as monopole, but yeah, that's basically what you're trying to do anyway, in some sense.
Yeah, more or less. It is a very bizarre thing. So anyway, these are the type of experiments, and the people that are opposing this, of course, they think that pouring salt in an egg and water is an experiment that, like I said, we didn't all do in second grade. And, people wonder why I really want nothing to do with these people. And I just don't. I don't, you guys are always asking me about that. And it's like, look, I have tried so hard to mend fences with these guys, but they just don't. I mean, they constantly make up lies. They make up stories about me supporting child rape, all because we have a different opinion on gravity, by the way. They do think it's just asinine what they do. They block me from even being able to talk to them, and then say that they've been trying to talk to me for 2 years, and just lie after lie after lie. And I'm sick of them. Honestly, I don't care anymore what they do. I'm not going to pay any attention to them. And I'm sure a lot of you know who I'm talking about, but I'm certainly not going to give them the airtime other than to say that they purely disgust me. And I think that they are doing some really bad damage to the flat earth community. And honestly, I will say this: if you are in that camp, great, then be in that camp. I have nothing against you being in that camp. All we're doing is presenting our evidence and asking you to use your head and your senses and go with what you think is right. And if you still think that that is the relative density disequilibrium is the correct choice, then fine, go with it. But I'm just tired of arguing with it. Now what I want to do is discuss it and move forward with this model. Okay. And I want like-minded people to be in on the discussion. I am not going to debate it anymore. I will be happy to talk about it, but I will not debate it, period.
Well, once this foundation's laid down, then you can move forward to other things that, stem from these ideas. So I think it's a good way forward.
Yeah, and we're not claiming to know what is causing, these electrical and magnetic fields that we see around us and is manipulating the matter. We don't know, but
we have ideas.
do know, and we can, but we can test what happens inside a magnetic field and what happens inside of an electric field. Those are the things we're testing. How the electric field is manipulating the matter. It can be tested.
Yes. And that's what we're going to do. So, like I said, and everybody that wants to, go on this journey with us, you're more than welcome to come along with us. That's great. But all of us are just tired of the argument, when when your show is so bad that Globers don't even want to go on and debate you anymore, then, you know, the best thing you have to do then is go after flat earthers, and make up outrageous stories about them and try and debunk what they're doing. Then you know that you pretty much hit bottom. And that's where this other camp is at. And we simply don't want anything to do with them. So there you have it. All right. And that's all I'm going to say about that. So guys, do you want to, should we take maybe a call or two? Do you want to do that? You guys up for that?
Yeah, sure.
Absolutely.
Okay, so let's go ahead. Let me throw the ticker up here. And guys, so basically it's going to be tinyurl.com/GB as in Globebusters 0318, today's date. And, you know, I would appreciate it if you would keep the subject matter to what we have talked about today. And, you know, what your take is on it, and, you know, what you would like to see, any suggestions you have, anything like that. That would be great. But, you know, like I said, as far as a debate, I don't want to debate. I want a discussion. And I think that's the best way to handle these things. Because honestly, if anybody's ever listened to debate shows around here, wow, what a cluster screw. I mean, they're so bad. I just don't know how, and nobody can ever get a word in edgewise. It's so bad. So anyway, let me type it in here. Hang on a sec. https tinyurl.com/GB0318. That looks about right. There you go. Oh, and let me put it in the DLive. Hey, and DLive's actually working today. I can't believe it. Nice.
All right.
Yeah, we didn't have DLive working on Sunday. So that's cool. All right. Can someone type it in here, the link? I just did Wisdom, a Full Weakness. It's right there, the tiny URL right there. I'll put it in a few more times. Okay, cool. And, you know, we may not get any calls on it yet because people, like I said, I did kind of hand out a homework assignment. And like I said, I really do want people to be up on this before we enter into the discussion, because guys, this is going to go a lot further than here. And we just got somebody in. All right, so Luke, let's bring Luke in. And how you doing, Luke? You're in with the Globebusters.
I'm good. I'm good. I'm from Trinidad actually. I just want to talk on the same experiment, go a little further on it. That you're doing, but because I have a few ideas, like if you take the same magnet and you force the like the two sides together, and you clamp them together, and you add like but you make like several magnets like that, and you put them close to each other, but you contain them, you restrain them from touching each other, and you put like coils inside. You will pick up like a small voltage. I just and next something I've done, and I've gotten like like 1 volt, but I use a very small magnet when I test that.
Okay, yeah, I know exactly what you're talking about. That's called inductance, and what's happening is you're just inducing a magnetic field through the coil, and that's generating a voltage into it.
Yeah,
and,
but but I'm not moving the magnets or the coil. It's just the field that moving, because when the two sides force together, the field it's just non-stop moving.
Wow.
So it creates a voltage in the coils itself, producing current. So I studied if I upscale it and I make a bigger one, like the size of magnets all they're using, I will get like 10 volts or 12 volts around there. So I just study it.
Wow, that's awesome.
Yeah.
I'm gonna try
cool.
that. I've never seen that before. Putting them, you know, not coherent but backwards, and it kind of makes sense. You wouldn't even need to move the magnet. It's already both moving in both of those directions.
I did it already.
Wow.
And I get a LED to light for a very long time. In fact, it never stopped. It never stopped giving off light until I dismantled it. Because it keep lighting.
Yeah, I've seen things like that. That's super interesting, isn't it?
Yeah, we're going to have to play with that.
Yeah, but it doesn't even need to get the huge magnets to actually upscale one to make a bigger one. So it's come like you're getting free energy because you're using the ether now to get the energy.
And it is. It really comes back to that too, the ether manipulation. And of course, as always, Einstein mathematically eliminated the ether, and the mainstreamers, would like us to believe that the ether doesn't exist, even though they will call it the quantum field. They'll call it any other name in the book and give it the exact same attributes. But calling it the ether is just a sin. You can't do that. So it's ridiculous. And all this, I think, is to keep people from discovering free energy and, things like what you've come across. So very cool.
Luke, how do you actually measure the potential difference, the voltage? Or where do you attach the two probes or whatever?
Well, you make when you're making a coil, you make a positive and a negative.
Like when you said you measured a 1 volt.
1 volt. Well, the only way I get to measure, I didn't really use a multimeter to measure the volt. I attach a LED, a 1 volt LED, and the LED glow.
Okay, but where did you attach the 2 points?
2 points. Well, negative to positive, or anyone because I know negative to positive, they can't tell which one, so I just attach to wherever.
Okay.
You can't really tell which is negative and which is positive because you force the two sides together, so the field is all how so you just attach and it get light. But it was but the glow wasn't bright though. It was.
And that's why an LED would work, because you don't need a negative. You don't need. It doesn't matter if you attach it to negative or positive to negative. Okay, brilliant. Wow, that's really cool.
Okay. So somebody could have tried, on a big scale, use a bigger magnet. Because the magnets I use was very small, like a quarter.
Nice, beautiful.
The magnet, you should get more voltage.
Okay, all right.
I'm definitely going to try that. Thanks, Luke.
For sure. Thank you, Luke. You have anything else for us?
Well, I've other ideas with that same magnet poles forcing each together idea like to create a anti-gravity system. But you see what like if you force the two sides together and you move it and you feel like a resistance in the magnet, a kind of like a soup. So if you're like but it will be dangerous because if you're getting a motor and you spin it, but not too fast, but slow, you should get it to go up. Like,
is that like the Searle type effect?
Yeah, it does not too, but I never tried, but it should move up. But you don't even have to spin it fast, you just have to spin it like very slow, and it should like levitate. It's just a theory, I never tried that one. I want it. Just ideas and test out and
you need to make some videos, Luke.
Yeah, you do.
I love time.
All right, Luke.
Because of security, so I don't really have time to really do any videos.
All right, Luke. Well, thanks for the information and appreciate you calling.
All right, thanks.
All right, you take care.
Cheers, Luke.
Cheers. Okay, so let's bring in Flat Matt. Hang on just a second. And Flat Matt, how you doing? On to the Glowbusters.
Doing well. How are you?
Not too shabby. What can we do for you?
Just kind of popping in. I've talked to you before on a Geocentricity show as well and stuff. I don't know if you remember me on there, but no one always keeps talking about like how we should go to Antarctica and get an expedition together and everything. Not sure if that rings a bell to you.
Yeah, actually, I do remember that.
It does to me.
Same stuff, doing the same stuff here. Just kind of wanted to pop in. I'm not really fully in the know with everything that you're talking about really too much, but just kind of to throw, if I get off the topic and you want to bring me back on, that's fine, But yeah, I've been hanging out with Jake the Asshole he's been hanging out. He actually crashed on that futon right there. But he's a good guy. I know he's kind of intense and stuff like that. I feel like there's some sort of like a thing between like I don't know if it's like Jaren and him or something, but like I don't know, whatever, dude. I don't really care much. You know, you guys all seem pretty cool with each other to me. But anyway, yeah, no, I don't know. You guys want to talk about your gravity thing, or do you want to get in on this Antarctic expedition we're putting together here?
No, I'd love to hear about your Antarctic expedition, but I do kind of want to keep it to the gravity thing.
Yeah. Tell me what's going on with that, 'cause I don't really know what you're talking about. Well, there's a debate going on about something. I know I'm supposed to know, and I don't. I'm sorry.
Well,
yeah.
The debate about what gravity, so-called gravity, actually is, and you know, there is a flat earther. There's a one side of the flat earther position, another side of the flat earther's position, and then a mainstream position, right? Yeah. And I guess you could call it maybe even a fourth position, but there's a lot of differences of opinion on what gravity is. And whether or not it even exists. And, you know, what we're saying is that there is something that is causing a downward acceleration. Absolutely, because we have instrumentation that can measure it all day long.
Well, yeah, it's obviously there's an acceleration.
Yeah, obviously. I mean, that's you know, I mean, people that deny that, it just floors me. It is so obviously there.
Yeah,
that
it's not even worth even like recognizing it. You know, I wouldn't get hung up on that. Like, obviously, acceleration is measurable.
But there is a camp within flat Earth that is saying, nope, doesn't exist at all. Everything is relative density disequilibrium. There is no need for the downward acceleration force. And I could not disagree with that more. And that's, you know, basically.
Even if there is the layering, right, that they all talk about, you just talk about the layering, I mean, there still would be an acceleration to the appropriate layer. And there is a speed in which that accelerates to the new buoyancy or whatever. So, I mean, either way, we call it tomato, tomato, there's still an acceleration occurring, right?
Yeah, absolutely. Yes. Oops. Okay. So anyway, that's kind of what it's all about. And it's getting heated to the point where it's ridiculous. You know, when you have accusations of flying, of people being planted agents, you know, me specifically, right? And I'm trying to ruin the flat Earth community and all this stuff because, you know, I happen to see gravity in a different way. And then there are other people that have absolutely no science background or acumen whatsoever. And they have elected themselves, you know, the knower of all scientific things because they understand, you know, the steps in a scientific method, which most people now at least do, especially if they've been watching them. But I just don't understand this animosity, and you know, frankly, I'm just sick of it. So,
I mean, down is down, and down is up, you know. And there is an acceleration. I mean, obviously, we're all getting pulled down. Like, I don't know. People talk to me about that topic sometimes. I talk about flat Earth, and you know, being a flat earther, you're going to talk to people all the time about, oh, does gravity exist and all these things. And to me, I'm just like, you know, like your opinion as a glober, I'm like, you think that we're getting pulled to the larger object, which is the Earth. Which is which way, which is that way. So I'm just saying that, you know, like this is how I explain it. I'm just like, the big massive object is that way, obviously, is down. I'm just saying that the Earth is flat and that mass is below us, and we can be getting pulled right down to that, just like you do on a globe. You get pulled down to the larger mass below you. You know, I mean, that's the logic can fit either way. You know, it's like, who cares? Either way, down is down. Like, even if you use globe map, like the globe concepts and stuff, it still works the same, you know?
Yeah, exactly. And the downward acceleration is equally needed in both models.
Yeah.
There's just no two ways about that. You know, but like I said, it's been misapplied by the globe model, you know, as this thing that pulls into the center of a sphere. And I will tell you, I'll be the first to tell you that even Ken Wheeler seems to think that that's what's going on with it. And, you know, there could be a case even made for that. But the reality is that, you know, when you're a flat earther and you understand that this isn't a ball and that it makes so much more sense that, you know, we are in between a gigantic capacitor plate, right? Two plates of a capacitor, and we have an electric gradient, which is measurable and absolutely there. We have all these things that we can prove this with. So it's like, well, why don't we just go with the stuff that we know is there and stop dreaming about the helio nonsensical model that nobody can even find curvature, right?
Yeah. That sounds right. You know, I think you're on it, and I wouldn't let too much of the naysayers get to you or anything. Yeah, clickbait in their own way type of thing.
Yeah, well, I'm not. Like I said, I'm not even going to be including that anymore. But you know, a lot of people are saying, "Oh, well, you just don't want to talk about it." It's like, no, with them, you're right. I don't, and I won't. There's too many other people out there.
It's like once you're in the topic for long enough, you want to dive a little deeper. You know, it's kind of like having the same conversation with normal people thinking the Earth's a globe and being like, "Well, actually, you can see pretty far," and you know, it's time to start from square one again, right? It's like at some point you got to move on, you know, to the deeper details, you know, that are actually like important, you know.
Yeah, exactly. And that's what I want to do is simply move on. You know, we have this concept of the luminiferous ether. We've been talking about it literally for years, you know, and it all kind of arose out of this whole, you know, the Behind the Curve movie, you know, and the experiments that I did with the fiber optic gyro. And that really got me into understanding what the luminiferous ether was and how it behaved. And when we were able to actually model its behavior using the fiber optic gyro, it blew me away, you know? So now I know it's the real deal, you know?
Yeah. Yeah. You were on that movie, right? The Netflix Behind the Curve.
No, I am the man that has been credited with proving the rotation of the Earth.
Yeah, that was just to like, not to talk about this, but like, you know, my buddy Jake, dude, we went throwing disc golf the other day. He's my boy, and he was saying that the problem he has with like people who went and were associated with that movie is because everybody knew, as well as you probably did, that like they're gonna spin it against you, right? You know, obviously Netflix is gonna come out and be like and try to make you look like an idiot, like the globe is a globe.
Well, unfortunately, no, I have to admit I was naive. We didn't believe that because we were told by the producers themselves and the guy that filmed it, he goes, no, we actually really want to give a very pro flat Earth point of view on this. And we really want to, you know, paint you guys in a favorable light. And then when they went to the Flat Earth International Conference in Raleigh, it was at that conference when a 10-year-old or something stood up and said that he was a flat earther. And, you know, then they all of a sudden decided, they said, and this is their own words, that they decided at that point that it wasn't funny anymore, that kids were getting involved, and they had to do something to stop it. So that at that point, they were going to take an active stance against it, which may or may not be bullshit, because I think, honestly, what they were motivated by was knowing that the mainstream wanted to debunk this so bad that they just were looking for somebody to put a hit piece out on us. And, you know, unfortunately, yeah, I guess I was pretty naive because I really thought, and so did all of us, they thought that they were going to try and paint us in a favorable light. But live and learn, right?
No, you know, and I could see you making that mistake. You definitely got to think, like, if it's going on Netflix, they're probably going to twist it against you, and you have to figure that's more than.
Well, we didn't know that. That's the whole thing. Is Netflix. They didn't even know Netflix was going to buy it. That's just something that happened later. But, you know, this was just going to be a small grassroots thing that was supposed to show at a film festival, right?
Yeah.
We had no idea that, you know. So obviously, what happened was Netflix came to them and said, "Look, if you paint these guys in a completely terrible light, then we're going to buy this from you for big bucks, because we're going to market the hell out of it, because we'll do anything to shut down the flat Earth movement."
Yeah, you know, and along all these lines, just in general, like, you know, flat Earth, like, man, there's only so many of us. Like, we get heat. Just any if you think there's flat, and then you think that there's anything else, you know what I mean? Like disagreements on this or that or the other, like, man, stronger together, you know? And that's how I feel, dude. Like, there's only a couple people out there where you're like, oh, okay, they're probably shills, right? That type of thing. Like, but there's not many. We know there's going to be one snuck in here or there, right? Like, that's kind of comes with the territory. But I just think that we should all, you know, try to help each other more, and not to get too far off, but I just, business-wise, if any, like, I really think that if we can get something going where there's, like, you know, mutual support in our businesses, you know what I mean? If there's anyone that has a business or even looking for jobs or something like that, you know, like, I think there's a lot more that can be done with the community, since we're all kind of get pushed against, and we're all, it'd be helpful to be more, you know, beneficial to each other and supportive and stuff in general.
Well, yeah, there's a lot of people moving to this South Carolina region. And some of them are actually looking into getting some serious amounts of land and starting like a little, you know, community.
Flat Earth commune, eh?
I'm sure it'll be called a cult, you know, right off the bat.
It already is.
Waco your ass, but yeah, good sentiment, Matt. I agree.
Yep. Cool. Okay, Matt. Well, thank you for calling. You have anything else you want to share with us, or?
Oh, not really. You know, I'm just whatever. I'm doing my thing. I guess my channel. You know, and I probably never will get 100,000 subscribers. If I do, then I'm going to go try to cross the Antarctica, rent a private jet and stuff, and go across. If anyone wants to come, they're welcome. I know it'll probably never happen. This is just kind of my little effort.
Yeah.
Other than that, I have, I mean, not to plug myself, but I have like a free, I'm working on something called 10athletes.com. It's my business. It's all free. Everything's totally free on it, but just something I'm building that helps people find other people to play sports with, like kind of get out and do stuff. That's my business. That's like what I do for a living. So, but whatever, just throwing that out there. Anyway, thanks for letting me say that. And nice talking to you again for sure, and appreciate you having me on and everything.
What was the name of the business again?
I'm building it right now. I have 2 engineers that are working on it right now, like full time, you know, and working hard on it. I'm the founder CEO guy. It's a startup, you know. I'm in Sacramento. I'm doing startup. This is my startup. It's like my dream. It's called 10 Athletes. So it's 10athletes.com.
10 athletes. Okay, cool.
Yeah, it's crash right now. It looks really bad right now. Like I got people working on it where it's like we're pre-launch, you know, we're pre-MVP, but that is what I'm doing, you know. So, but yeah, everybody gets rated from 1 to 10 in any sport that they play, tennis or ping pong or whatever, and then you can find other people about as good as you to play sports with. You know.
Oh, that's awesome. That's cool. Yeah, I would have used that back in the day if it was around for sure.
Hey, see, it's cool, man. Anything you play, you know, ping pong or pool or something, like it's a broad definition of sports. So.
Yeah, awesome. I garden now, man. I don't know if there's any gardening sports out
Competitive
there.
Competitive
gardening. Maybe a cornhole.
Yeah.
No, that's a good cause, Matt, and could easily be configured to be used for flat Earth contacts.
Yeah, definitely. I mean, I'm in the community building, like, you know, industry, I guess, in a way. So, you know,
it's a great cause. Yeah.
Well, awesome. Well, thanks for coming on and filling us in. Appreciate it.
Yeah, definitely. Nice talking to you. Hopefully I'll talk to you again sometime.
Okay, Matt. Sounds good. Have a good one, man.
Easy.
Take it easy, Matt.
Later. All right, cool. And next up, we have John Bernhard. So let's go ahead and add him to the stream. And how you doing, John?
Okay, I'm fine if you hear me.
Yeah, I hear you just fine.
Okay, all right, man. Do you remember a long time ago we were talking about people don't understand the ether?
Yeah, I remember it like it was yesterday.
Yeah, okay, wow.
Yeah, John, are you exiled from Iceland?
Yeah, I'm exiled from Iceland. Yes, I am.
I thought I'd spoken to you before.
Yeah.
Good to hear you again, man.
The same to you. Yeah, time is flying past by so fast.
Yeah, it really does.
Every week is like a year, but.
So do you have a particular take on, you know, anything we've been talking about as far as, you know, gravity or the nature of it, or what are your thoughts on it?
I have the whole packet if you want.
Okay, I'm interested in the packet.
Really? Okay, don't talk about that.
Okay.
But I will keep on talking about the ether. You know, people don't understand what ether is. True,
they really don't.
So I want to say it in the ether. First, it's in electronic, it's no ether. It's other technique. But before the computer technology and everything, like we are talking together just now, then we had analog technology, and we were sending the voice out to the ether, and every people working in the radio say all the time before the old time, you know, you remember that, Bob? They say, okay, now we are sending this out to the ether.
Mm-hmm.
Yeah.
Yes.
And that was because the radio waves waves have to go through the ether to come to you.
That's exactly right. The ether is the medium which the radio waves, RF waves propagate.
Exactly.
So, absolutely right.
So I'm just saying that so people understand what ether is. Ether is the placeholder and the medium that is feeling that you can send it through. And this medium is full of like a water, but it's not water because it's like many things, of course. It's a liquid.
Well, everything, I mean, the way I'm looking at it is everything manifests out of it, and it's basically done cymatically. So the ether is this base material that when you speak or vibrate it, right? When you apply vibration, right, and frequency.
Yes.
So when you put vibration and frequency and you modulate the ether with it, it literally manifests into everything. And it's really cool because, you know, if you've seen some of the Hans Jenny original cymatics videos, they can apply multiple frequencies into like Lyco powder, and what it will do is it will look like living organisms, like spinal sections, hearts, lungs, things like absolutely blow your mind type of stuff, all done by simply modulating with frequency and vibration, these Lyco powders.
Yeah. I will just say also, it's about fluid. Everything is fluid in the ether. Fluid materia. So
yes.
Yeah. Okay.
And I think fluid is Tesla said that the ether was more dense than any matter.
He did. Yes.
That the field is so compact that, you know, for the matter to be able to compact together, even the densest matter, it had to be able to work within that medium.
But that can be wrong. That can be misunderstanding also, because nothing is absolutely.
Well, and not only that, or you can simply look at it as, it could be extremely dense, but it could also be very, very spread out. Right?
Yeah. Exactly.
So yeah, I mean, I get that concept, and I'm certainly not going to try and disagree with what Tesla said, but to me, it makes sense that, you know, whatever it is something that, you know, it brings our reality into creation vibrationally, and there's just no way that I think it could be anything else. Honestly, that's really how I see it working.
And we have to go deeper into the vibration and the frequency and everything what's about. And we also have to understand in the atmosphere, the electric power is more if you go higher from the Earth. And Earth is minus, and everything in the atmosphere is plus. You know, if you go higher up, it's more energy there.
Yeah, I agree with that. And there are also other things, you know, like in Lucas's model, he's showing the sun and the moon as, you know, additional anodes and cathodes. And I guess I would see them more as type of control grids. But I mean, you could liken it to a vacuum tube type of construct. I mean, there's so many possibilities as to how it could actually manifest out. But the fact that it is an electrical construct is inescapable. And I think that's basically the bottom line of what we have to work with. And I really think that the electrostatic model and the electromagnetic model are just different modalities of the ether, just like water, ice, and steam are all different modalities of water, right? So to me, that kind of thinking makes sense. It's reasonable, it's logical, and it's something that you can actually build a functional model off of. Now, whether or not it's right or not, who knows? Some of it we may be able to prove, some of it we may never be able to prove. But, you know, I'm just sick of being in a position where you just deny everything and say, well, I don't really know, and that's my answer to everything. I would just as soon try and figure it out, you know, even if I'm wrong. So
and everybody have to think about it. It's very systematic, exactly how the electricity in the air is Steve-Magnet gradients. Exactly, you can calculate it. The velocity in the hour, but how you are going up.
Yes, testable.
You can testable. Yes, it's testable, and you can try it. You can measure it. So
and the electric field is affecting matter in one way. The magnetic field is affecting matter in another way. And that's one of the reasons I don't like when they throw electromagnetic field together. Because they're both there. They're both kind of the same thing, but they're affecting matter differently.
Yeah. Well, I wouldn't say they're the same thing so much as they are. You have electromagnetism, and the magnetism, of course, can be created by static, by electricity, and electricity in turn creates magnetism. So they're kind of reciprocals of each other. Go ahead, Lucas.
No, that's all right. Yeah, I was going to say something similar. It's almost like they're at right angles to each other.
Exactly. Yeah, that would be about right. In fact, that's exactly what they say they are. If you listen to Eric Dollard, that's exactly how he describes it. That the dielectric is actually at right angles to the magnetic and electrostatic planes in manifestations.
Which is exactly what we see here on Earth. I mean, if you stick your thumb down in the center of the North Pole, the right-hand rule holds firm with the way the magnetic field moves and the way that the north is going, or the positive is going down into the Earth.
Yeah,
and it can be flowing through a wire almost.
It can be the explanation for the gravity, falling down, acceleration. Everybody's talking about the acceleration. Yeah, what is that? What is that? Yes, it's exactly that. It's about the electricity in the air, and it's about. I don't think it's about the static. I think it's just like you can do it in every electronic thing you are doing. If you are making something electronic, you just make a switch. It's like a switch.
It's a potential difference. Is that what you're trying to say?
Yeah. Thank you.
Okay.
Cool. Oh shit! Thank you.
Awesome. No problem.
And that potential difference is a gradient. So yeah.
Yep, that it is. Absolutely. Well, would it be a potential difference or an actual difference? Well, a gradient, I guess.
It's just between the two polarities. Yeah.
You can really get wrapped up in semantics on that, but yeah.
Well, yeah, there's electrostatic potential, and then there's just a plain old electric potential. And where you have the point-to-point, that's electric potential, and then electrostatic potential is like the field. It's not point-to-point, it's radiating between two surfaces or off of one surface. That's the difference between electrostatic potential and electric potential. Like electric potential is lightning. Lightning doesn't happen everywhere on the plane all at the same time. It doesn't discharge everywhere. Excellent. You have that electric potential difference in between the cloud and the Earth in those 2 points.
Yeah, and the other big point that people have is the word incoherent, right? Incoherent versus coherent, and when really it's a very, very simple concept. Incoherent is kind of scattered about. It's not exactly a focused type of energy. A laser beam is a coherent form of life, and it's light, and it's extremely powerful. You can take a 25-watt laser and it'll cut holes through the wall, or you can read by a 25-watt light bulb, right? Big difference. Same goes for electricity. If you have coherent electricity, then you can have like pointed lightning strikes that are extremely powerful. And then you can have incoherent, which is, more or less what the gradient is. And although there's actually energy there, it's not nearly as potent, right? So I don't know what the problem is understanding, incoherent and coherency, but there is a huge difference, that those two words define.
Yeah, well, you explained it very well there. That makes sense.
Oh, well, cool. Thanks.
It sounds like you're right on, Bob.
Oh, well, thank you. Beautiful. All right.
Good to hear from you again, John. And I look forward to returning to Iceland with the future king, Bernhards.
I want to be the new president. So I need all of your stuff.
You got my vote.
All of it you can give me.
Okay, John. Well, any final words before we let you go?
Just I love Globebusters and hope we will live so long we can. Hold you up.
Oh, thank you. Appreciate that. All right, sir. Well, you have a great day, and we'll see you on Sunday.
Thank you very much.
Okay. All right. And so we're going to go ahead and close down the lines. So we're not going to take any more incoming calls. And I do want people to know that on this coming up Sunday, we have ODD TV that will be joining us. Cool. Along with Karen B. And ODD is going to come on. And of course, Matt and I have been friends for a long, long time. We were neighbors in Colorado. He's my ping pong partner, and he's a great guy. I really like Matt a lot, and we've been friends for a long time.
Yeah, very down to earth. For as big as the guy is, well known in the rapping community and all that kind of stuff, he is very mellow and just down to earth and just a normal guy. He doesn't wear it on his sleeve or anything like that.
No,
yeah,
very down to earth. So I really like Matt. So, and again, if you guys can make it to the Solar Return Festival on the 26th and 27th of this month in Greenville, South Carolina, the tickets are $77, I believe. And if you have kids, they get in free with an adult having a paid ticket. And you go and get that at flatearthfestivals.com is where you want to go and do that. And thank you, Karen B, for setting that up for us. And yeah, that's awesome. So anyway, guys, hopefully this got us to at least a point of introduction. And I think on our next episode, which hopefully we'll pick up again following Wednesday, then we can start going into Lucas's model and other extrapolations of this electric Earth model. Does that sound good to you guys?
Brilliant.
Mm-hmm. Sounds good.
Like a plan.
All right, cool.
Enjoyed it.
Yeah, awesome. So I guess let me, John, I'm going to ask you if what you got coming up or anything you want to see coming up. We'll do our customary closeout and then we'll shut her down. So
yeah, I've got absolutely sod all coming up. I'm still in lockdown here in the UK, and it looks like they're now extending it from June to 2022, I think. Who knows? I don't watch the news anymore, but yeah, I'm in the process of building a garage workshop shed because I'm sick of watching all these YouTube videos of Americans DIYers, and they just take it on over to the belt sander and then over to the drill press and then over to the bandsaw, and I haven't got any of these things and I haven't got room for them. So I'm working on that, and I've got two 13-year-old kids that would love to start doing that sort of thing, and foundries and all sorts of stuff. So yeah, not putting out anything on the flat earth front, although I think my blog is called Savage Plane at WordPress.com, but the best way to get to it is to go to a Google search. It has to be Google, and search Einstein and shitbag, and you'll get it straight away.
Savage Plane will be the first two that pop up.
Yeah, and that's one thing I didn't mention is all three of our guests today, Good Times for All, Zach, John Savage, and LCKing, are all part of Iron Rome Media. And yeah, that escaped me because I forget, Lucas, you recently became pretty much a full-time member, and of course Zach is, and John was one of the OGs that was in Iron Realm. So yeah, and they do their show on Fridays, I believe at 6 Eastern, and then you also do really early morning shows at 5 a.m. Eastern on Tuesdays and Friday mornings, right?
Yep.
Mm-hmm.
Yep.
Awesome. Okay, cool. So Lucas, let me kick it around to you. You want to go ahead and share what you're doing? And
well, I'll still be just doing research on some of the things I've been looking at lately, which is the concept of what Mercury's doing in our environment and how that's maybe part of our system. And yeah, so hopefully doing some more videos on that sort of thing if I get a chance. And yeah, being a part of IRM and hanging out with those guys. So you can come over and talk to us.
Awesome. Sounds good. Yeah, and I will, the video you just put out, I'll watch that this evening, but I did see you put it out and just didn't have time to watch it today. So I'll get on that this evening for sure.
Oh, good.
So, all right, cool. And last but not least, Zach, what do you got coming up, sir?
Well, I've been tossing around doing a Polaris video. I did one, years ago on my phone, and it was like a half-hour long, and I talked through it. I didn't, I'm getting it down better to where I type it out, I do the audio, then I put the video to it, and I'm getting more of my flow. So I think I'd like to redo that one because I still hear ballers in some of the like the 24/7 debates and stuff like that coming up with this Polaris nonsense about how it changes and it, processes and all this stuff. So yeah, we're gonna put a nail in the coffin of that one. I think that's my next video. I'm just working it out in my head right now. Yeah, it's so obvious, so it won't be too hard.
Yeah, because that's just point blank a lie. Polaris is and always has been the pole star as far back as recorded history goes. And, even, there should be a minimal precession for it of a few degrees. And they'll say, oh, no, it has moved a little bit. But no, it hasn't moved anywhere near enough, ballers, not even close to near enough.
Yeah, 27 degrees it should have moved now since Ptolemy named it over 1,800 years ago. Over 27 degrees. So no, it hasn't moved.
Yeah, precession of the equinox is part of the global eye for sure.
Mm-hmm.
Yeah, there is no precession of the equinoxes. That's just utter nonsense. And of course, it's always something that, like NASA, everything is always beyond your capability to test it. And you just got to trust NASA, even no matter how ridiculous it sounds. And believe me, it usually does sound pretty damn ridiculous. But yeah, that's the way it is. So cool. All right, guys. Well, thanks for joining me tonight. And again, we will normally be trying to do this on a Wednesday night. I had a wicked toothache on Wednesday, and I did not feel like doing it yesterday at all. And I'm much better today, even though I'm sure at some point I'm going to have to go to the damn dentist, and I hate going to the dentist. But I suppose it's better than dealing with that tooth pain because, man, that was brutal. So
get a pliers.
Yeah, right.
Bottle of Jack Daniels, job done.
Yep, just go for it, no doubt. Yeah, the last tooth extraction I had was brutal. Oh my God, felt like they ripped my head off.
Well, thank you so much for having me, Bob. This was awesome. I had a lot of fun.
Yeah,
likewise.
Thanks, Bob.
All right, no problem. All right, guys. So when we come back, it will be on a Wednesday this time. I forgot about Jaron doing his show on Thursday, and I apologize to Jaron for that. I don't mean to cross over tracks, and because I know everybody enjoys Jaron's show as well. So we'll try and keep them on separate nights. But still, we did pretty good. We had over 600 people between this and D Live. Not too shabby, but whatever. That's great. So we will see you guys next week. Until then, be good to each other. Don't lie to each other. Open your mind because there is truth inside. Peace out, everybody.
Peace.